Hello everyone. In this video we are going to learn LangChain from scratch. So this is a crash course, so I will explain everything in a simple way. Even if you are a beginner or you can understand this. Okay, we will build a real thing like chatbot, reg system and AI agents. And we will use free Grok API, so no cost. Okay, so by the end of this video you will be able to build your own AI application. So let's start. So first we need to understand what is LangChain. LangChain is a tool that help us build application using AI, or we can say using AI model. For example, chatbot, question answering system and AI assistant. Without LangChain, everything is messy. LangChain makes it structured and easy. It connect LLM, data and tool. What is the LLM? LLM is a like brain. Okay, and data is knowledge and tools is a actions. Okay, so think of LangChain is like a bridge between AI and real world apps. So guys, I hope you already know about this. I am going to use here .ipy env file inside this Visual Studio. Okay, so here I have created one folder, one what is this here, one and LangChain. Okay, and here I have created one env file. Okay, that I can I can put here my Grok API key. Okay, so you can go here. Okay, you can go here, find out your Grok API key with the help of this. Okay, click on this link and now you can go here in API key section and then you can create your own API key. Okay, something like this. You need to put one name here, LangChain. Okay, and then submit. You need to create your own, don't use my. I will delete this. Okay, I will delete this API key that you are not going to use this. So here in this I'm going to pass my Grok API key here. Okay, and after this you can see I am going to create one project. Okay, after complete basics. Okay, and this is our requirement.txt. Here we can install, I mean we can put the library and then we can install. Okay, and here this is the file langchain underscore crash underscore course. Okay, and this is our project file, project underscore chatbot. So I will create project with the help of LangChain. Okay, and this is our main file LangChain underscore crash underscore course. Okay, so in this file we are going to learn what is the LangChain and what kind of component we have inside the LangChain. Everything. What is the agent, what is the reg, what is the memory. Okay, so here I'm going to open this. I'm going to close this. Okay, so LangChain crash course, it may be 3 to 5 hours. Okay, so here we are going to use Grok API. Okay, and we are going to learn setup and installation, LLM and chat model with Grok, prompt template, LCE, LangChain expression language, output parser, memory and conversation history, document loader and text splitter, embedding, vector stores, and retriever augmentation generation. Okay, reg. After this in end we will learn agent and tools. Okay, so you can get your free Grok API key at this website. Okay, https consolegrok.com. Okay, I already show you this website, consolegrok.com. Okay, so here you can see setup and installation, first step. Okay, so here you can see what is LangChain. LangChain is a framework for building application powered by LLM. LLM means large language model. Okay, so you can see here this diagram. Okay, so first we need to understand, let's understand this diagram. Okay, first user ask the question here. Okay, like what is your name, something. User ask the question, where is India. Okay, and what is the weather in Bangalore, like this. Okay, so here user ask the question. Okay, first user ask the question, then we create a prompt. Okay, here we create a prompt. Prompt means how we ask the question to AI. Okay, then this will goes to the LLM here, large language model. Okay, this prompt will goes here in LLM. Okay, LLM is the brain like GPT or llama. Okay, and after this LLM generate a response. LLM generate a response. Okay, then we use output parser here. Okay, parser convert response. Parser convert response into a clean format. Okay, with the help of parser we can get a clean format. Okay, and finally we get the answer here. Okay, so this is the basic flow of LangChain. Okay, user ask the question, then we create a prompt. Prompt means how we can ask the question to AI. Okay, then this goes to the LLM here, and then LLM generate the response here, and then with the help of output parser we get proper clean format of our response. Okay, then we got here our final response. Okay, so parser, this one is going to convert response into a clean format. Okay, so finally we get here our answer. So this is the basic flow of LangChain. Okay, and inside the LangChain we will have, we have chains. Okay, chains means sequence LLM call. Okay, sequence LLM call means in LangChain we connect things like this. Okay, prompt, LLM and output. Okay, so this is called the chain. Okay, this is called the chain. So chain means step by step flow. Here you can see we connect prompt with LLM and then we got output. Here you can see here prompt, LLM and an output. Okay, so this is called the chain. We connect something sequence by sequence, or we can say step by step, in step by step flow. Okay, so here input goes in a, processing. Okay, input goes in and processing happen and outputs come out. Okay, and this is very simple. Okay, and now we have memories. Okay, but before memory we will understand RAG. I'm going to explain memory 1 minute. Okay, so this is our RAG. Okay, so what is the RAG? Its full form is retrieve augmentation generation. Ground LLM in your own data. Okay, like if you have your own data, or then you want to create something, then you need to use RAG. Okay, so let's understand RAG. RAG means retrieve augmentation generation. Okay, okay. Simple meaning of RAG: we don't depend only on AI knowledge. Okay, simple meaning of RAG: we don't depend only on AI knowledge. Okay, we also give our own data. We also give our own data here to the RAG. Okay, we also give our own data to the RAG. So step by step you can see here, user ask the question. Okay, user ask the question here, then we convert question into a numbers. Number is called the vectors. Okay, here user ask the question, then this question convert into a vector. Vectors is a number. Okay, then we convert question into a number here. Okay, user query, we convert user query into a number. Then we search in a this database. Okay, we search in a database, we get here relevant data. Okay, and then we send that data to the LLM here. Okay, so RAG makes AI more accurate and generate here final answer. Okay guys, so first user ask the question, then we convert this question into a numbers or vectors. Okay, and then we store this into a vector database. Okay, okay, and we can search inside the vector database here, and we get the relevant data and send to the LLM, and LLM generate the final answer. That's it guys. So this is the simple process of RAG. Okay, so RAG means retrieve augmentation generation, or when we will use this, so we don't depend only on AI knowledge, we also give our own data. Okay, now we will understand agent. This is the agent. Okay, so agent, what is the agent? Agent are smart. Okay, agent are smart, they can take decision. Agent are smart, they can take decision, they can use tool. Okay, agent are smart, they can use tool, and they can take decision. Okay, so with the help of agent, like if, like for example user ask what is 10 into 20, agent will use calculator tool and get the answer and return the result with the help of agent. Okay, so here you can see let llm take a action with tool, they can take decision, they can use tool. Okay, so agent, why I got call. So guy, agent take a action. Okay, with tool they can take decision, they can use tool. Okay, and agent equals to brand plus action. If you ask something to the agent what is 2 into 10, sorry, 10 into 20, then it will automatically calculate this and get the answer and return the result. Okay, so it can think and act, agent. Okay, now we have memory equals to what, remembering something. Okay, persistent state across cell. Memory means remembering thing, like a chat history. Okay, so memory means remembering things like chat history. For example, I'm going to say my name is Nidhi. Okay, then I'm going to ask, hey, what is my name? So AI remember and answer that you are a Nidhi. Okay, so memory help in a conversation. Okay guys, I hope you got it. Chat equals to, in LangChain, we connect something like this: prompt, LLM, and output in step by step. Okay, and memory means remembering something. And agent means, okay, like they have brain and action, they can take decision. Okay, and RAG, like if you have your own data and you want to connect your own data with LLM, then it will generate the answer. Okay, you don't depend on AI knowledge only. Okay, you also want your own data, so that then you can use RAG. So we have these four main topics: chain, memory, agents, and RAG. Okay, and here I'm going to use grok. Why I'm going to use grok? So with the help of grok we can run everything here. Okay, so grok provides blazing fast interference on Llama 3, Mistral, and Gamma model, all free on the developer tires. Okay, so with the help, Grok is totally free. Okay, and we can access different kind of model with the help of Grok. Okay, if you are going to search here Grok model, so it will give you models. Okay, so that is available free. Okay, so we can use this kind of model. Okay, so we have some amount, it is going to charge some amount, but some model is totally free. Okay, so we can use model from here. Okay, like you are, if you are watching my video, then you, maybe you are a fresher or you don't have budget to buy some model or API key, so that's why I'm going for grok. Okay, so I'm going to use grok here. Okay, and here I'm going to install langchain. Okay, langchain grok. Okay, so these are the package I'm going to install. With the help of grok, I'm going to use grok models. Okay, and here I'm going to install langchain community. Okay, and langchain hugging face. Okay guys, hugging face I'm going to use here. Okay, so guys, these are the previous libraries. Okay, that I'm going to use in this project. Okay, so finally we are going to install here some libraries or package. Okay, from, you can see here, pip install langchain. Okay, so what is it? So langchain is a main framework. Okay, we install langchain here, this is the main library. Okay, then we install langgraph. Here you can see this one, sorry, langchain grok, this one, not langgraph. Okay, so here this is our second library. It help us to connect to the grok model. Okay, then we have langchain community, this one. Okay, so it gives extra features. Okay, and I have this langchain hugging face. Okay. So LangChain having this used for embedding. Okay, and here I have files CPU. It means we are going to use this library for store and search the vectors. Okay, and then we have sentence transform, convert text into a number with the help of this sentence transform. Okay, now we have PDF. So why we use this? So it help us read the PDF file. Okay, and then we have .env file, sorry, .python hyphen .env. So this is used for this file, this one. Okay, so .env is used to store the API keys. Okay, and here I use this duck search. Okay, so duck search are used for searching something on internet. Okay, and we install this stimulate used for UI. Okay guys, so don't worry. Okay, if you don't understand, you will understand after some time. Okay, so here I'm going to install this. I need to uh, hit on shift and enter button, shift plus enter. Okay, it is going to install here. It is taking some time. Okay guys, so one by one everything is going to install here. Okay, now you can see everything is installing here, is still pending. Okay, so we are not writing API key directly in code. Okay, so we store it in our .env file. Here you can see here, this one is our API key. Okay, so here I'm going to write code for this. Okay, so here I'm not going to write API key directly in code. We are going to store it in .env file. Okay, and then we load using load underscore .env. Okay, so here I'm going to write line from .env. From .env I'm going to import load.env. Okay, and I'm going to import OS. Okay, and here I'm going to create one instance load.env. Okay, so this is used for load the env file, parse the env file and load all the variable found as an environment variable. Okay, so that's why we use this. And here you can see what does it mean. Parse the .env file and load all the environment found as a variable. Okay, so these are used for access the env file. Okay, that we can access API key from the env file. Okay, and here I need to write variable name that I have inside this grok API key. Okay, so here I'm going to close this. I need to mention here grok API key. Okay, so grok API key equals to OS dot, I'm going to use this get env. This one. Okay, means get the API key from the env files and variable name is what, this one. Okay, and I'm going to write another line as that. This is for error. Okay, like if API key is not going to find out inside our env file, then we can use this. Okay, so if grok API key is not in env file, if API key is not none, so it is going to answer API key missing. If API key is not none, okay, it answer API key is missing. Okay, And here I need to mention print setup complete. Okay, so here you can see here from .env I'm going to import load.env. Okay, so import .env to load the value from .env file, and import os means import os to access the environment variable. Okay, load underscore .env, it load all variable from .env file, okay, into the system. And we have this one, so get the grok api key from the environment variable with the help of this. Okay, and here check if api keys exist or not. Okay, if not, it will stop the program and show the error. Okay, otherwise it print everything is correct and print the success message. This is the setup complete. Okay, I'm going to run this, so it is saying like setup complete. Okay, so here this will, I mean, this is used for upload the api key from .env file. Okay, now let's understand llm. Okay, llms and chat models with grok. Okay, so llm means large language model. Okay, it is the brain of our ai system. Okay, it is the brain of our ai system. It can understand text and generate the answer. Okay, so these are the model, grok model, key grok model, all free. Okay, so you can see here we have these model. Grok give us different ai models. Okay, grok give us different ai models. Each model has different power and speed. Okay, each model has different power and speed. So you can see here, let's see some models. These are the models: llama 3 hyphen 8 billion 8192. Okay, this is the fast and good for normal task, this one. Okay, and you can see here the second one, llama 3 70 billion 8192. This is a more powerful. Okay, better for complex question, this one. And mistral, this supports long text. Okay, good for documentations. And gamma 2 9 billion hyphen it, it is a good, okay, at the following instruction. Okay, so you can see here context. What is the context? Context means how much text the model can handle at the one time. How much text model can handle at one time. More context means it can read more data. Small context means it can read small data only. Okay, so this model can read 8k context. This model can read 8k context in one time. Okay, and this model can take 32k. Okay, 32k text, okay, at one time. And this model can read 8k text in a one time. Okay, so context mean how much text the model can handle at one time. More context means it can read more data. Okay, and this one is best for general task. This one is used for complex reasoning. This one used for long document, and this one used for instruction following. Okay. Okay, so these are the model provided by the grok. Okay, so here you can see two way to use llm in LangChain. First is chat grok. Okay, first is chat grok. This is the modern way. Modern way, it work like a chat. We send message like system message and user message. Okay, so this is the recommended. Okay, so this one is the modern way, it work like a chat. Okay, so chat grok equals to chat models, recommended, and users. Okay, and here we have grok. Okay, so grok, second is a grok. This is the old style, we just send a simple text prompt. Okay, no chat format, so we will modify and we will mostly use chat grok. Okay, so chat grok is modern way, it work like a chat. We send the message like in the form of system message and user message with the help of chat grok. Okay, so we will use this in our code, and this is the old style. Okay, this is the old style, we just send the simple text prompts, no chat format. Okay, so we will mostly use this one, chat grok. Okay. Okay, so think like chat grok. Chat grok chatting with ai like a WhatsApp. Okay, and grok just sending one message without the conversation. Okay, So always prefer chat grok for better result. Okay, so here we are going to write code. Okay, so now we will connect our AI model. Now we are going to connect these AI models. Okay, you can pick one, you can use any. Okay, so we will connect our AI model using chatgrok. Okay, this is the brain of our application. Okay, we will choose a model and set some basic setting like creativity and response length. Okay, so here I import this line from LangChain underscore grok. I'm going to import chatgrok. What does it mean? So import chatgrok class to use grok model in LangChain. Okay, now I'm going to initialize. So here I'm going to mention this comment here. Okay, so I'm going to initialize LLM equals to chatgrok, this one. Okay, so initialize the chat model. This create our AI model. Okay, so inside this I'm going to pass model name. Okay, so I'm going to use model that is llama 3. Guys, I'm going to use llama 3 hyphen 8v hyphen 8192. Okay, and then I need to put here what, actually 1 minute guys. Actually I'm just going to import one line from LangChain grok. From LangChain grok I'm going to import chat grok. Okay, so this line import chat grok class to use the grok model in LangChain. Okay, and here I'm going to initialize the chat model. This create a AI model. Okay, so LLM equals to chat model. I'm passing here model. Okay, so I'm going to use this model llama 3.1 hyphen 8 billion parameter instance. Okay, this is also very fast model and lightweight. Okay, and temperature equals to 0.7. What is the temperature, guys? Temperature give the randomness in your output. Okay, so 0, if you put 0 in temperature equals to 0, it means it is it will give you output deterministic. Okay, and 1 means creative. Okay, so it will show you randomness. Okay, and maximum token equals to what? Okay, so 1 minute. 0 means same answer every time, less creative. Okay, and 1 means more creative and random answer. Okay, and maximum token 1024, maximum length of the response, number of the word and tokens. Okay, and here I'm going to print model name to configure everything is working or not. Okay, so print model, and here I'm going to use this LLM and model underscore name. So it is giving us model name. Okay, so I'm going to use this model. Okay, and so here we are creating our model, our AI model. Okay, and temperature control creativity, maximum token, this one maximum token control how long the answer will be. Okay, and now our model is ready to use because this one. Okay, now I'm going to write code here. Okay, so here now we will send a simple question to our model. Okay, this is called the invocations. We give input and the model give the output here with the help of this. Okay, so here I need to mention response equals to, I'm going to use this LLM. Okay, here I have model, temperature and maximum token. LLM dot invoke. Okay, so basic invocation means simple way to call the LLM. Okay, Invoke means ask something. ENVOKE, invoke. Inside this, I'm going to pass one query. What is LangChain? What is LangChain in one message, in one sentence? Okay, this is the question I'm going to ask. Now we send a question to the model and store the answer in response. Okay, so here I'm going, actually I have some code here. Okay, this one. So I can copy from here, okay, and paste it here. Okay, response equals to llm dot invoke. This llm invoke what is the LangChain in one sentence. So print type of response, I mean AI message object. Type of response giving us AI response message. So here you can see it is giving us this one. Okay, type of response LLM core message AI message. Okay, so this is AI message, and after this I have two line. Okay, so print the type of response. With the help of this we can print the type of response, and this, so the response is an AI message object, not just a plain text. Okay, and here we have response dot content. Okay, I'm going to print this response dot content. So I got this content. Okay, response the actual answer text. Dot contents give us the real output from the model. Okay, response dot content, it is giving us the real output from the model. And here with the help of this response dot usage metadata. Okay, so print the usage details. Okay, this so token, number of token. Okay, token usage and how much input and output token this one, and total token of this one. Okay, so here, okay, so this is our response here. Okay, now we are going to move here. So here simple we use here invoke, this one. Invoke means to send the message to the question to the model. Okay, the model return the response object. Inside that we get the actual answer using dot content. Okay, so we can also see the token users, number of tokens, amount. Okay, then here I came here. Okay, so guys, response equals to full reply. Okay, full reply object. And this one invoke means asking a question. And response dot content I use this one, so this is giving us actual answer. Okay, so after this I have two type of message. Okay, now instead of sending simple text we will send a message. Okay, here instead of sending simple text we will send a message. Chat model work like a conversation. Okay, so we can give the instruction and user question separately here. Okay, so I have code, maybe, yes I have. Okay, so you can see here this one. From LangChain underscore core dot message I import system message, human message, and AI message, system message, and human message. Okay, so import the message type, like message from human, message from system, message from AI. Or we can give the message to is AI and system. Okay, so here message equals to, in list we have two type message, system message and human message. In system message we have content equals to you are a helpful Python tutor, we coincide. Okay, so here we are passing system message equals to instruction for AI. Okay, so here with the help of system message we are going to pass instruction to AI that you are a helpful Python tutor. Okay, and human message equals to, here inside the human message content, what is the list comparison. Okay, human message means user question. Okay, so these are two messages I use, system message and human message. Human means user question and system means we are going to provide the prompt to the system. Okay, and now I'm going to print something. Okay, so here I'm going to print response equals to here. Now I'm going to send message to the model. Okay, response equals to llm dot invoke. Okay, I use these two lines. Response equals to, sorry, this line response equals to llm dot invoke. Instead of this, I'm passing this list of message. Inside this we have system message and human message. Okay, so response equals to llm invoke, I pass this message here. Okay, and print response dot content. This will give you original content. Okay, so here I'm going to run this. So I got this answer. A list comparison is coincide with creating a new list from the existing list. Okay guys, so this is our response, and this is also giving the code here. Okay, example you can see here for list comparison. Okay, and this is the example we use nested list comparison to the flatten a list of list. Okay, so here we are using message instead of plain text. System message give the instruction to the AI. System message give the instruction to the AI, and human message is the user question. Okay, the model read both and give the response here. System message like teacher or instruction, and human equals to student question, and AI equals to AI answer. Okay, with the help of model. Now we have another line. So here I'm going to write code here. Okay, list get token as they are generated. Okay, so now we will see the streaming. Instead of waiting for full answer, we get the output word by word. Okay, just like ChatGPT typing effective. Okay, just like ChatGPT typing effect. Okay, instead of waiting for full answer, we just get the output word by word with the help of streaming. Okay, so here maybe I have code here. Yes, this one. So guys, here you can see streaming get token as they are generated. Get token as they are generated. Streaming equals to get the token as they are generated. Okay, and this is for display the better result. Okay, and this one I use loop for chunk in llm dot stream. Okay, so loop over each chunk coming from the model. Chunk means, what is the chunk guys? Okay, piece of text. Okay, like if we have a long paragraph, long context, then we need to convert into a piece of chunks, small chunks. Okay, like this we can take 5 chunks at a time, then we can take again 5 chunks at a time, like this. Okay, so a small piece of chunks. Okay, so here I'm going to use loop over each chunk coming from the models. Okay, for chunk in llm dot stream. For chunk in llm dot stream. Okay, so here I use tell me 3 fact about the Python programming. Okay, and I'm going to print chunk dot context. Okay, and it is going to provide the answers of chunk. Okay, and here end, I use end means keep everything is in same line. Okay, and flush equals to true means print output instantly. Okay, real time effect. And print, there is nothing, means new line at the end. Okay, so I'm going to run this guys like this. Okay, so here you can see I'm going to run again. Okay, so instead of waiting for full answer, we got output word by word. You can check here, we got output word by word. Okay, so with the help of streaming. Okay, so streaming get token as they are generated. Okay, so after this, so here we don't wait for all response. Okay, the model send small chunks, we print them one by one. ओके गाइस, यहाँ पर छोटे छोटे जो चंक हैं वो एक बार में मॉडल दे रहा है, फिर दूसरी बार में, तीसरी बार में, इस टाइप से छोटे छोटे चंक दे रहा है. ओके, सो वी प्रिंट देम एज वन बाय वन. Okay, so normal invoke equals to full message at once, and streaming means typing effect like ChatGPT. Okay, so here after this, streaming is useful for better user experience in app. Okay, now I'm going to move here, prompt equals to this. Okay, so now we will see batch processing. Batch processing here. Okay, batch processing, batch means run multiple prompt at once. Okay, so instead of sending one question, we send multiple question at once. Okay, this is a faster and more efficient. Here we are going to send multiple question at once. Okay, batch run multiple prompt at once. Okay, and list of question we want to send together. Okay, and here you can see response equals to llm dot batch. Inside this I pass this prompt. Okay, so send all prompt at once to the model. Okay, response I use llm, this llm. Where is it, guys? This llm. Okay, and inside this I use batch. Okay, to take everything from prompt. Okay, and I put here prompt as a variable, this one, so it will take these three. Okay, so here send all the prompt at once to the model with the help of this line. Okay, and model return a list of response in same order. Okay, and here I use loop through each question and its answer. Okay, so I use prompt and response, so loop through each question and its answer. Okay, so question I have inside the prompt, and this is the answer in response. Okay, in gif, so it will take both prompt and response at a time, so that's why I use gif here. Okay, so loop through each question and its answer. So here it is going to print, maybe I have this one here, so I'm going to print prompt, and print prompt means question, and print answer response dot content. Okay, and from 0 to 100 it is giving text into a answer, and this is for new line. Okay, so print first 100 character of the answer. Okay, and this one is used to print the question. Okay, I'm going to print here. Okay guys, so it is giving us answer. What is the Python? It is going to take prompt and response. So response is Python is a high level interpreted programming language that widely used for various response. Okay, so this is our answer of first question. Okay, then we have second question, so it is giving us answer for second question. Okay, and this is our third question, what is rust, so it is giving answer. Okay, now we are going to move here in prompt template. Now we are going to understand prompt template. Okay, so I think you don't know prompt template, but okay, after this you will get it, what is it. Okay, so now let's understand prompt template. Prompt means the question or instruction we give to the AI. Prompt means the question or instruction we give to the AI. Okay, but writing the same prompt again and again is not efficient. Okay, so we use prompt template. Okay, so you can see here prompt template equals to prompt template allow you to create reusable dynamic prompt with variable. Okay, so I'm already saying prompt means question or instruction we give to the AI. Okay, but writing the same prompt again and again is not efficient, so we use prompt template. So type of prompt template, chat prompt template, few short prompt. Okay, so you can see here prompt template is like a fixed format. Okay, prompt template is like a fixed format. We create one template, then we just change the value inside it. Okay, and think like this, like it is like a form. It is like a form, you have fixed format and you just fill the blank. Okay, so same here, we create a prompt with placeholder and fill values later. Okay, so this is our first prompt. First is prompt template, this one. Okay, this is for simple text prompt. Okay, prompt templates here, this is used for simple text prompt. Okay, we write a sentence and use the variable. So for example we have one topic. Okay, topic to a level student. Okay, so for example we have some query like this: explain topic to a student. Okay, so this is like a simple prompt or simple text prompt. Okay, so we, with the help of this prompt template, we need to write simple string prompt. Okay, and second is simple, with the help of this we use simple text plus variable. Okay, and second is chat prompt template for chat style prompt, most common. Okay, mostly we use this chat prompt template. Okay, second is chat prompt template, this one. This is used for chat model. We write message like system message and human message. I already show you here this one, system message and human message, with the help of chat prompt. Okay, so chat prompt we write message like system prompt and human, sorry, system message and human message. Okay, so this is the most commonly used. Okay, so analogy maybe you can use like chatting with AI step by step. Okay, and again we have another prompt template, that is few short prompt template, include example to guide the LLM. Okay, so this is the few short prompt template. Here we give the example to the model, so the model understand better that we use that what we want. Okay, so example, we show input and output, and then model learn the pattern. Okay, so we can say here in one line, few short, sorry, prompt template is equals to simple, chat prompt template is equals to chat style, and few short prompt template learning from the example. So we are not changing the logic, we are just making the prompt reusable and clean. Okay, so now let's see how to use prompt template in code. Okay, so I have, okay, so you can see here, 1 minute. 1 minute. Okay, so now we will create our first prompt template here. Okay, instead of writing prompt again and again, we will create a reusable prompt. Okay, so I'm going to import something, this one, this line from LangChain, underscore core dot prompt. I'm going to use prompt template. Okay, so here I'm going to import prompt template from the LangChain underscore core. So this is our inbuilt, okay, pre-built library, this one and this one. I'm going to use prompt template by using this. Okay, and I'm going to create template with the variable now. So here you can see basic prompt template, user use variable placeholder. Okay, so template equals to prompt template, input variable, here I'm giving topic and labels. Okay, input variable, this is our name of the variable. Here I'm giving topic means you need to give any kind of question, or if you have any topic you need to search. Okay, and inside the template I'm passing explain topic. Okay, to a level, so I pass here label also, what kind of level, like beginner, experience. Okay, so explain topic to a level in a 3 bullet. Okay, so this is a template with variable. Okay, template with a variable. So here we are created a template, topic and label. Okay, topic and label are variables, we will replace them with real values. Okay, and now guys, these are a variable, we can replace it with the real value. Okay, you need to write some topic instead of this. Okay, so here after some time, okay, so here maybe I have this. Okay, I'm going to copy this and paste it here. Okay, format prompt by filling the values. Okay, so formatted equals, this is another variable from formatted. Okay, template, I use this template. Okay, and I put format, I want format. Okay, topic equals to neural network and level equals to 10-year old. Okay, it's like experience, 10-year old student है जिसको हमें explain करना है topic, what is the neural network. Okay, and inside this I use this template and I want this, I want to use this format. Okay, okay, and print the format, and this is for new line, empty line, whatever. Okay, I'm going to run this, explain neural network to 10-year old in 3 bullet point. Okay, and now I have these two lines. Here you can see here, print the final output. We are going to print our final output here and here. Okay, so now I'm going to create one variable, that is response. Okay, now I'm going to send prompt to the LLM with the help of response. Okay, so LLM dot invoke. Okay, invoke means asking something. Okay, and I'm going to put this formatted here. Okay, in this format. Okay, the topic is neural network and label is 10-year old. I need to pass this here. Okay, and print the response dot content. Content means simple text. Okay, so it generate the text by with the help of LLM. Okay, so here this is the answer. So here are three simple points to explain neural network to 10-year old. Okay guys, so this is the topic, explain neural network to 10-year old. Okay, topic this and 10-year old student, this is the label. Okay, and image a brain, a neural network is like a computer version of the human brain. Okay guys, so these are the topics, three topics: making prediction, learning from example, and imagine imagine a brain. Okay, so we created a template here. Now we send it here, we created a template, this one. Okay, and now we send it to the LLM here. Okay, after formatting, so instead of writing full prompt again, we just reuse the template here. Okay, so write once, use many time. If you forget to pass variable, it will give the error. Okay, here, this one. Now I'm going to write something different. Okay, now we will use chat prompt template, second prompt template, chat prompt template, this one. This is used for prompt template. Okay, now I'm going to write code for chat prompt template. Okay, chat prompt template here, chat prompt template. Okay, okay, chat prompt template. So now we will use chat prompt template. This is the modern and recommended way. Here we talk to AI using message just like chat. Okay, so I'm going to import chat prompt template. So I have code here, maybe 1 minute. Actually guys, this is the crash course. If I'm going to write by my own everything, then it will become long. Okay, so this is only crash course, so that's why I'm going to take from here. Okay, so inside the chat prompt template, so you can see here from LangChain underscore core dot prompt, I'm going to import chat prompt template. Okay, so we can access chat prompt template with the help of this library. Okay, and now create the chat template with the system and human message. Okay, so chat template equals to chat prompt template. Okay, from message, so these are the message, system message, you are an expert, domain teacher, always be encouraging. Okay, so here we are just giving the prompt, system message set the behavior of AI, system message set the behavior of AI. Okay, and human explain the concept in a simple term. Human message means actual question. Okay, asked by the human. So system message define the how AI should behave, and human message is what we ask to AI. Okay, and now again I'm going to use format. So here we have format. Okay, so format return a list of message. So fill variable inside the template. Okay, so I use another variable message equals to, I pass this chat template, this one. I pass both of them, these message, system and human, with the help of chat underscore template. Okay, and dot format underscore message. Okay, so it will return a list of messages. Domain equals to machine learning and concept equals to gradient descent. Okay, so these are the topic from machine learning. Okay, so here it will here replace the domain. Okay, this one you can replace anything, and concept replace the concept here. Okay, and here this is like fill the variable inside the template. Okay, so this is our template and we are just going to fill this domain and concept. Okay, with the help of this. Okay, now we have this uh, I mean these lines. Okay, for message in a message. Okay, so here print the each message. For message inside this message. Okay, print type of message and dot name and message dot content. With the help of this we will get the content and print. This is for new line. Okay, so you can see we have different message. Okay, different message types, system message and human message. This is how chat model work internally. Okay, I'm going to run this. So you can see here it is going to print type. Okay, type is message, type is system message, and and type of its human message. Okay, and message dot content, you are an expert machine learning, always be encouraging. Topic is explain gradient descent in simple term. Okay, so here we using the chat format, we send. Here we use chat format. Okay, chat format. So here we have, I mean we send a system message and human message. Okay, so here we are using chat format and we send system message and human message. Okay, system message tell AI how to behave, and human message is the question of human, and this is the better than a simple prompt. Okay, now we have another prompt. What is it? Few short prompt. Okay, okay, so system means instruction and human means your answer, your question, your message, and AI reply to you. So this is called the AI message, guys. Okay. now now we will send our message to the AI model. Now we are going to send our message to the AI model. These messages include system and human instruction. Okay, so I have code here. Okay, you can see here. Now we will send our message to the AI model. Okay, and these messages include system and human instruction. Okay, so here this line, call the LLM using message. Okay, response equals to, this is the variable name. I'm going to call LLM. Where is our LLM? In starting we have this LLM. Okay, inside this have model, temperature and maximum token. Okay, so here you can see I'm going to call the LLM here and asking. Invoking means asking question or message. Inside this I pass message. These are the message domain. Inside the message I have domain, what is machine learning and concept gradient descent. Okay, and I pass here and it is going to print the response. Okay, here. So we are saying invoke function to send, we are using invoke here. Okay, we are using invoke function to send the message to the model. Okay, and the model will process them and generate the response here. Okay, so print this one, print response dot content. So only print the actual response. Okay, so this response is not just a text, it is an object, so we can use dot content to get the answer. Okay, so I got this answer. You are the first step. Amazing world of the machine learning. Okay, so this is the answer. What is the gradient descent? Okay, so what is the domain? Machine learning, and concept is gradient descent. So it is going to explain gradient descent. Gradient descent is a powerful optimization algorithm used in machine learning to find the best parameter for a model. Okay, how does it work? Imagine you are standing at the top of mountain with a map. Okay, so guys, this is like generate the response with the help of this prompt. I mean with the help of this. Okay, now I'm going to move for another prompt. Okay, so now we will use few short prompt template. Okay, here we teach the model using example, just like a teacher show example to the student. Okay, so in few short prompt we need to give examples. Okay, so should I mention here in comment few short prompt? Okay, so I need to copy something, some lines from here. Okay, so from LangChain underscore core, I'm going from prompt. From LangChain underscore core dot prompt, I'm going to import few short prompt template. Okay, so we will use here. So here few short prompt template equals to teach the model with the example. Okay, so example equals to word happy, antonymy and antonymy, sorry, word equals to happy and its opposite sad. Okay, word equals to tall and its opposite short. Okay, word equals to fast and its opposite is slow. Okay, so here example data input output pairs. Okay, so these are the example we are showing the model what we expect. Okay, so here after this I can use one example. Okay, so you can see here example template for each example, template for each example. Okay, so here I pass the input variable. Inside this I have inputs word and its opposites antonyms, synonyms and antonyms. Okay, and template equals to word. Okay, here I pass this word and opposite word with the help of this variable, this one. Okay, I pass both of them, and here this is how each example will look. Okay, and after this create a few short template. I'm going to create few short template. So this is our few short template. Okay, so here this is our few short equals to, this is the variable name. I'm going to use this template. Okay, inside this I pass example, these are the example. Okay, example prompt, inside this I have input variable and template. Okay, that it will take word and its opposite word. Okay, and prefix equals to give me the antonyms of each word. Okay, suffix equals to input here. Okay, and input variable equals to input. Okay, so here 1 minute. So here example equals to list of example, and this one example underscore prompt format of each example, and prefix equals to instruction at the top, and this one equals to new question at the end. Okay, new question at the end, and input variable equals to new input variable. Okay, so prefix is the instruction, example come in the middle, and suffix is the new question. Okay, now print the output. Now format it. So here fill new input equals to, so here fill the new input. So formatted equals to, this is the variable name guys, I put this few short. Okay, inside this I want this format input equals to write. Okay, so print with the help of this fill new input. Okay, and print equals to formatted means print the final prompt. Okay, and this one is for new line or empty line. Okay, so llm response equals to, I'm going to call llm here, invoke and ask the, I use here format, inside the format I have this. Okay, and it is giving us content here. Okay, call the llm. Here we are just going to call the llm. Now we send this full prompt to the model. So this is our model is going to call here. Okay, so here you can see give the anonyms of each word. Okay, word happy equals, sorry, word equals to happy and its opposite is sad. Okay, word is tall and its opposite is short. What is fast and its opposite is slow. Okay, what is bright and it is not giving here this one. Okay, so LLM response the anonyms of bright is dark. Okay, so anonyms of, okay, so bright is dark. Antonymy of bright is dark. So guys, this is the antonymy. Okay, so I have difficulty to pronunciate this pronunciation of this. Okay, so bright is dark. Okay, bright का opposite क्या है? Dark. Okay, this is the input I provide here, bright, and it is giving us dark here in response. Okay, so we show example to the model here. Okay, and then we ask the new question, this one. So model understand the pattern, give the correct answer. Okay, okay, so like teaching a child, and first you show the example, like teaching a child, and you show the first example, or you can show the, or you can show examples, then ask a new question, child learn a pattern and answer. Okay, so we are not training the model, we are just guiding it using the example example with the help of example, it learn the pattern and generate the answer, new answer. Okay, okay, so after this I have completed this. Now we have these lines of code. Okay, so here now we will make our chatbot remember past conversation. For that we use message placeholder. Okay, now we will make our chatbot remember the past conversation. गाइस यहाँ पर मेमोरी यूज होगी क्योंकि वो पास्ट कन्वर्सेशन को उसको याद रखना है. ठीक है, सो आप ऊपर वाली लाइन पे ध्यान देना, यहाँ पर जो मैं लिखूंगी नॉट. ओके, सो आई एम गोइंग टू टेक these 4 lines. Okay, so here I'm going to import from LangChain underscore code dot prompt. I'm going to import message placeholder. Okay, and chat underscore with underscore history. I use chat prompt template. Okay, this one I use here, chat prompt template. Where is it? This one. Okay, so I use chat prompt template here, and I mention dot form underscore message. Okay, so create a prompt with history placeholder. So in this I pass system message equals to you are a helpful assistant. Okay, message placeholder here I provide variable equals to history, inject the history here, and human, and this line is the place where past message will be inserted. Okay, and human equals to inside the human I pass the input like what is your question. Okay, and after this now we create a fake conversation history. Okay, so with the help of this I can create fake conversation history. Okay, history equals to human message, inside this I pass content equals to my name is Nidhi, and AI message here, in AI message nice to meet you Nidhi. Okay, so here we are creating fake conversation history. Okay, that we have past conversation like this. Okay, so now we send history to a new message. Okay, so this is our new message. अब मैंने हिस्ट्री को न्यू मैसेज सेंड किया है यहाँ पर. Okay, so this is our another variable, message equals to chat with history. This one I'm going to call this chat with history dot format underscore message, and message I'm going to send in the format of history, this one. Okay, and input equals to what is my name. Okay, and after this what I'm going to do here, I'm going to ask After asking, I'm going to print response. Okay, so here response, I'm going to call here LLM. Okay, call the LLM. So now model will see past message and answer correctly. Okay, so here response equals to LLM invoke message. I pass this message and print response dot content. So here it is going to print what your name is Nidhi. Okay, so here I use memory for past thing or past history, past. So guys, we pass old message. These are our old message. We pass old message and then we ask the new question. Okay, so model use past conversation to the answer. Okay, so like chatting with a you, I mean, if you like chatting with a friend. Okay, friend, remember what you said before. Same here, we give the history to the model. Model does not remember automatically. We manually pass the history here. Okay, so history plus new message equals to better answer. Okay, maybe without history it will give you wrong answer, but with history it will give you correct answer. Now we move here in LCEL. Okay guys, so here now we will start LCEL. LCEL, LangChain expression language. Okay, chain. So LCEL means we connect different part using a pipe. Okay, we connect different part using the pipe. Okay, LCEL is the modern way to compose LangChain component using the pipe operator. Guys, this is the pipe. So here LCL means we connect different part using this pipe operators. Okay, like a pipeline. So data goes step by step. Okay, so if we have chain here, then we are going to connect here prompt with LLM with pipe operator. Okay, again I'm going to connect here LLM with pipe operator to the output parser. Okay, so here you can see benefit of the LCEL. It is used in built-in streaming and batching sync, easy to compose and modify, type shape with clear data flow and replace old LLM chain and sequential chain. Okay, so think like a factory. Okay, you think like a factory. Import goes in and then processing happen and then output come out. Okay, so here you can see I'm going to connect here prompt with model and then output parser with the help of pipe operators. Okay, so now we are going to write step 1 here. Okay, so now we will learn LCL. LCL means we connect component using a pipe. Okay, so data flow step by step. First prompt runs. Okay, here you can see first prompts run here, then the model. Okay, and then the parser. Okay, so this make our code clean and modular. Okay, so here I'm going to import a chat prompt with a I'm going to import here chat prompt. Okay, chat prompt template from the LangChain underscore core dot prompt. So these are the inbuilt. Okay, this one also inbuilt. So with the help of this, I'm going to import st output parser. Okay, string output parser for output. Okay, that we will get the clean output. Okay, so LangChain underscore core dot prompt, I'm going to import prompt, and with the help of LangChain underscore core dot output parser, here I import output parser. Okay, and after this I'm going to create a chat prompt with a variable. Okay, so here, okay, so you can see here this line, create a chat prompt with the variable. Okay, so we have prompt equals to, I'm going to remove this, we have this prompt equals to, I used chat prompt template, this one, and dot home message, this is for message. Okay, from underscore message, inside this we have human message, and human messages tell me a objective. Okay, here I need to pass input joke about the topic. Okay, so this is the human input, I mean this is the human prompt. Okay, so I use here chat prompt template dot from message dot from underscore message, and now this objective and topic will be filled later. Okay, so you can fill here objective and topic later. Okay, so after this, create output parser. So here I'm going to create output parser. This is for output. Okay, convert message into a plain message. Okay, convert AI message into a plain string. Output parser. Okay, so parser equals to output parser. Okay, convert model output into a simple text. Output parsers mean convert model output into a simple text. Okay, or we can say AI output into a simple text string. Okay, after this, parser equals to string output parser, and after this we have these lines chain. Okay, so with the help of chain I'm going to connect this prompt here and LLM. I already use LLM here. Where is our code for LLM? This one. Okay, so output parser equals to, so I'm going to connect with the help of pipe operator prompt LLM and output parser. Okay, so this is our output parser for giving the plain string or clean answer in a text format. Okay, and after this I'm going to print. Alright, okay, so flow prompt format input, this one, this format the input, prompt format the input, LLM generate the response, and parser convert it into a clean string. Parser will be used to convert into a clean string. आउटपुट को clean string में convert कर देता है. Parser convert it into a clean string. Now we run the chain by giving input value share. So we have these lines. Result equals to chain dot invoke. Okay, invoke means asking something. So adjective means funny. Here I give input adjective equals to funny and topic equals to Python. Okay, and print the final result here, and here this one type of result. Okay, print type of the result. This will be, I mean its output will be a string because parser converted it into a string. Okay, so we will replace here adjective with funny and topic with Python. I'm going to run this. Okay, so why did the Python go to therapy? So this is the I mean topic. Okay, topic is Python, and this is giving us funny joke. Why did the Python go to the therapy? Okay, because it had a lot of hang-ups. Oh, so this is the result, and type of result, this one, class LangChain underscore core message dot base index. So this is the type of result. Okay, so here we create a pipeline. You can see here we create a pipeline. Okay, and the model run here, this pipeline. Okay, and model run, then parser clean the output. Okay, so final result is simple text like this line and this line. Okay, so without parser result is object, and with parser result is string. Okay, so after this I'm going to create another line. Okay, now we will see streaming. Okay, normally we get full output at a once, but with the help of streaming we get output word by word in real time. Okay, so I'm going to print here streaming joke. Okay, so here I'm going to use loop for chunk in chain dot stream. So I use this chain, and I'm going to apply a stream in this chain stream. Okay, and here inside this I need to pass objective. This objective. Okay, so objective equals to, मैं यहाँ पर I'm going to write terrible. Okay, so here this is the objective. I am going to pass comma here, replace it with objective. Okay, and here I'm just mention topic. topic should be AI. Okay, and now one bracket, अच्छा जी, for chunk in a chain dot stream, 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 objective, adjective, this one spelling mistake guys, this is an adjective. Okay, and adjective equals to terrible and topic equals to AI. Okay, now we use columns. Now it is going to print. So here print chunk and equals to, this is for like space, flash equals to true. Okay, chunk equals to small part of the response. Okay, a small piece of content. Okay, a small part of the response, and end means print the continuously on the same line, and flash equals to true means show the output instantly real time. Okay, and print the new line here. Flash means show output instantly real time. Okay, flash equals to true means, and print here new line. Okay, I'm going to run this. I got error. Object has no stream attribute. Oh, check 1 minute. For chunk in chain, where chain, this chain dot stream. Array, I put 2 time a. Okay, still got error. Flush is an invalid keyword argument for print. Okay, 1 minute. Maybe it's the spelling mistake here. FLU, flush. Okay, so you can see here our result. Okay, so it is not giving us full answer at once, it is giving us answer like this, like ChatGPT. Okay, so like typing in WhatsApp, it is giving us answer. You can see here multiple time. Okay, so you see message appearing wordviver here. You can see here message appear wordviver. थोड़ा पहले आ रहा, फिर थोड़ा पहले आ रहा, फिर थोड़ा पहले आ रहा, ऐसे करके पूरा आ गया. So without streaming you will wait, and with streaming you see live output. Okay, like this, and this is the output streaming. Why did the AI program go to the therapy? Because it was feeling a little glitchy. Okay, so every time it is giving us different answer. Okay, so after this, so it is giving us real time output. Okay, so after this, now we will learn batch processing. Instead of running one input at a time, okay, instead running one input at a time, we can send multiple input together. This is a faster and more efficiently. Okay, maybe I have a code here, input, this one for batch processing. Actually I have code here, I'm just going to copy and explain everything. Okay, so you can see here batch processing. Okay, batch processing means instead of running one input at a time, we can send multiple input together. Okay, this is a faster and more efficient. You can see here input equals to, in list we have multiple dictionaries. Okay, adjective equals to dad and topic equals to cat. Okay, adjective equals to nerdy and topic equals to database. Adjective equals to quick and topic is equals to cloud computing. Okay, and then here input 1, this is the input 1, input 2, and input 3. So in batch processing, we are, instead of running one input at a time, we just taking multiple input together. Okay, this is a faster and more efficient. So after this each item is a separate input for chain. Okay, so here each item is separate from each item separate input for the chain. Okay, so here I use this chain, and this is the result equals to chain dot batch input. Okay, so I use result one variable is equals to, I put this chain here, this chain. Okay, inside the chain I have prompt, llm, and parser. Everything is connected by chain here. Okay, and then I use batch because we are going to take multiple input, and inside the batch I pass the input. Okay, and I use loop here. So with the help of this, run all input together. Okay, and I use loop here. Okay, loop through result and print them. Okay, so I use for I and r in enumerators. Okay, so it is going to take its keys and values. Okay, and I are in enumerate result inside this result. Okay, and I pass one here. Okay, and print joke from, I mean, and I to R till the 18 character. Okay, and print the empty. So it's mean 80, this line 80. Okay, so only first 80 character. With the help of this, it is going to show you first 80 character. Okay, and here I'm going to print joke 1, joke 2, joke 3. So guys, here I means 1 2 3. Okay, and here R means joke 1, joke 2, joke 3. So it is giving us first 80 character. Okay, so only first 80 character. So here in joke 1, why did the cat joiner bend? Because it wanted to be pur. This is one I don't know. So why did the SQL join go therapy? Okay, so these are the joke 1, joke 2, and joke 3. I got this output here. Okay, so here we send multiple imports, model process all together, and we get the multiple outputs. Okay, like ordering multiple item at once instead of one by one. Okay, so it is a list of, input is a list. Okay, and output is also a list. So after this, we have another sequential chain. Okay, so after this, now we will learn sequential chain. So this output of one chain become input of next chain. Output of one chain become input of next chain. So data flow step by step like a pipeline. Okay, so here I can write sequential chain. One by one we will understand. Okay, so first I import here runnable pass through. Okay, sequential chain output become next chain. Okay, okay, so here in sequential chain, output of one chain become the input of next chain. So data flow step by step. Okay, so I import runnable pass through. Okay, so from LangChain underscore core dot runnable, I import runnable pass through. Okay, and here you can see topic prompt, this one. Okay, chain 1 generate a topic. Okay, generate a topic. So with the help of chain 1, we are going to generate a topic, and here I am going to create one variable topic underscore prompt, and here I use prompt chat prompt template. Okay, and dot from message, this is for message. Okay, and here I'm giving human message, give me one interesting topic in a field. This is the input, and replace with just the topic name. Okay, so this prompt take the field as an input and return the topic. Okay, and now after this, we have topic chain here. Okay, topic chain equals to, I pass this topic underscore prompt and llm and string output parser str. Okay, before I also use this one str parser output. So here this will convert output in a plain text or in a simple string, and this is used for llm. Okay, and this is used for this one. I just passed this prompt. Okay, And chain 2, here you can see chain 2. So in chain 2, first here, here, topic, this is the format prompt. Okay, format prompt, send to the LLM and convert output into a string with the help of this. Okay, in chain 2, write essay, this one, write about that topic. Okay, so essay underscore prompt, this is another very well. And here also I pass the chat prompt template and dot form message, and it's here inside this human prompt, write 3 sentences about the topic. Okay, so here this prompt take topic as a input. Okay, this prompt take topic as a input. ठीक है, so here it is going to take prompt as a, sorry, take topic as a input here. Okay, so here easy essay, this prompt take topic as a input here. Okay, so I'm going to create its a chain. So now it is the chain for this essay. So you can see here essay underscore chain. Okay, underscore chain, this is the variable name. Here I pass this prompt topic chain, and I use LM and output parts are for clean result. Okay, so this is the same flow. Prompt, I need to give the prompt here to the LLM, and LLM generate the output with the help of this. Okay, as a prompt goes here in LLM, LLM generate the output. Okay, so after this combine chains. Okay, I'm going to combine this and this chain, both chain here. Okay, so here you can see here I just combine output topic chain, output of topic chain, this one. Okay, and feed into a essay chain, this one, essay prompt, this one. Where is this one? Okay, so full chain equals to topic chain, I pass the topic chain, and lambda equals to topic chain, topic. Okay, and here I pass essay chain. Okay, so this one is essay chain and this one is topic chain, this one. Okay, so you can see here in step 1, topic underscore chain generate the topic, this one. Okay, lambda, this one, lambda is going to convert topic into a dictionary, topic here into a dictionary. Okay, and essay chain use that topic to generate the answer. Okay, so output of first chain become input of the second chain. Okay, so full pipeline. Now I'm going to create full pipeline. So result equals to full underscore chain dot invoke field quantum computing. Okay, run the full pipeline and print the final result here. Okay, full, here I mentioned this full chain and ask the question field equals to quantum computing, and I'm going to run this. So you can see error, quantum error correction is a set of technique used to prevent the degradation of quantum information. Okay guys, so this is the answer. Okay, so here first we generate the topic. Okay, in first we generate the topic here. Okay, and then second then we use that topic to write the content or essay here. Okay, so first choose brand, add filling, and final sandwich. Okay, so first generate the topic, then we use that topic to write the content, and so output flow step by step. Okay, each chain depend on the previous output. Okay, output of one chain equals to input of next chain. Hmm? Now we will learn parallel chain. In this, multiple tasks run at the same time. So instead of waiting step by step, we will get result together. Okay, so here we have code for this. Multiple chain. Okay, so I'm going to copy from here. Okay, so in this section, we are going to learn multiple tasks multiple tasks run at a same time. Okay, so instead of waiting step by step, we will get a result together. Okay, so this is called the chain parallel chain. So parallel chain means run multiple chain at the same time. Okay, so I use from LangChain underscore code runnable. I'm going to use runnable. Okay, import runnable parallel. Okay, with the help of run we can run our chain parallelly. Okay, and here I use runnable parts. Here we are not going to sequential. This is the sequential chain. We use this for sequential chain. Okay, and now this is used for parallel. Okay, parallel chain. So pros underscore prompt equals to chat prompt template dot from message dot from underscore message. Here I pass human message list three type of pros of technology in bullet point. Okay guys, so this is a simple prompt. And now we have these lines. This is the another prompt. Okay, this is a pros, this is for cons, advantage disadvantage. Okay, cons prompt chat prompt template dot from message, and here in human message I pass list three cons of technology in bullet point. Okay, so these are two prompts. Okay. Now we are going to create chain here. Okay guys, so we have pros prompt. This ask model to generate the advantage, and this ask model to generate the disadvantage. Okay, so here you can see pros chain equals to this one, pros chain. Okay, pros chain equals to pros prompt. Here I pass pros prompt llm and string output parser. So this will generate advantages. Okay, create a prompt here, then pass ll and send to the llm and generate the output and convert output into the string. Similar, this will say this chain will be used to write the prompt. Okay, and send this prompt to the llm and generate the output in a simple string. Okay, now I'm going to use parallel chain. Okay, this is the another variable. Here I pass runnable parallel, this one. Okay, and here I pass pros equals to pros chain. Here pros equals to pros chain, this one, and cons equals to cons chain. I pass both chain here in parallel chain. Okay. Okay, now I'm going to print. Okay, so result equals to, here you can see result. Okay, so both chain run at the same time here with the help of this. Okay, pros and cons. Okay, now result, run the parallel chain here. So result equals to parallel chain. I pass here and ask this question. Invoke means asking something. Technology python. Okay, it will technology जो है python है उसके बारे में. You need to return from pros. Okay, result of pros and cons, and print of result of cons. Okay, so ये हमें pros मिल गया और cons मिल गया. Okay, so these are the pros about python. Here are three pros of python: easy to learn, versatile and general purpose, extensive library and framework. And cons are slow performance, memory usage and security risk. Okay, so this is our output. Okay, so we run two tasks together here. Okay, pros and cons, we have two tasks, two prompts, and both run at the same time with the help of this parallel chain. Okay, or parallel means no waiting, both chain execute simultaneously, multiple tasks and same time execution. Okay, so now we have another last topic in section number 4, this one, runnable pass through. Okay guys, so you can see here runnable pass through. Okay, so now we will learn runnable pass through. It simply pass input as it is without changing it. Okay, it simply passes input as it is without changing it. Okay, we use it when we want original input along with model output. Okay. Okay, so here I am going to import from LangChain underscore code runnable, import the runnable pass through. Runnable pass through pass the input through the unchanged. Okay, so it simply pass the input as it is without changing. ओके, सो हमें जैसी इनपुट मिलेगी वैसी की वैसी हम पास कर देंगे, हम उसमें कोई चेंजेस नहीं करेंगे. इट इज सिंपली पास द इनपुट एज इट इज. ओके, विदाउट चेंजिंग इट. ओके, फ्रॉम LangChain underscore core runnable import runnable pass through. Okay, and here we use it when we want original input along with model output. Okay, so after this, here we have this variable chain underscore with underscore input. Okay, so useful when you want to preserve the original input alongside chain output. Okay, so here I pass runnable parallel, this one. Previously I used runnable parallel. Okay, this one. So I use runnable parallel. Here I pass original input. Okay, so here you can see original input. Okay, so runnable pass through keep the input unchanged. It just format the data as it is. Okay, like hello, अगर हमारे पास hello है तो वो hello को same to same ले लेगा. No modification happen. Okay, so here you can see response chain. Chain equals to chain with input equals to runnable chain, not response chain. And here I use runnable parser. Here I pass the original runnable pass through. Okay, for original input, and in response I pass chat prompt template dot from message, and here I pass the human message translate text to the French. Okay, and here I use LLM and string output parser. ठीक है, हमने ह्यूमन इनपुट को डायरेक्ट यहाँ पर LLM को दिया. Here we are just giving this human input to the LLM, and LLM generate the output in a single string format. Okay, so here format prompt. Okay, send here format prompt I send to the LLM here, and then it will convert into a string, simple output. Okay, and then we have these lines. Okay, result equals to so here we have these lines. Okay, so you can see here original, keep original input unchanged, I already explained, and generate the translated output with the help of this. Okay, and here I pass everything here, and this is our result run the chain here. Okay, result equals to chain underscore with underscore input, and I use invoke, and here I pass text equals to hello how are you. Okay, it is going to print original result, and it is going to print a French result. Okay guys, so you can see here original result hello how are you, and French result, this is the translation of hello how are you to the French is bonjour. Okay, so this is giving us answer in original and as well as French. Okay, so bonjour, good day. You can see here somewhere we have French and somewhere we have English. Okay, so here one part keep input same, one part keeps input same. Okay, this one, and other part process it, and I mean convert into a French. Okay, so we get both original and output. Okay guys, so like copying a text and translating it, you keep the original text and also get the translated version. Okay, so pass through does not change data, it only passes its format. Pass through does not change the data, it only passes it forward. It only passes it forward. Okay, so original input process output together here. However, a more casual and common way to ask how someone is in French. So it is giving us answer in French. Okay, so somewhere we have original and somewhere we have in English. I hope you got it. Now we move here in output parser. Now we'll learn output parser. Okay, now we'll learn output parser. When AI responds, it is usually raw text. Okay, raw text. When AI responds, it is usually raw text. But in real application, in real application, we need structured data like string, list, JSON, or object. In real application, we need structured data like string, list, JSON, or object. So we use output parser. Okay. Okay. So in real application, we use structured data like string, list, JSON, or object. So we use output parser. Okay, so output parser means we convert AI output into a usual format. Usual format. Okay, so when AI give response, it is usually raw text. Okay, but in real application, we need structured data like string. Okay, for a string, we use str output parser. Okay, and for dictionary, we use JSON output parser. Okay, and here with the help of string we got plain text, and with the help of dictionary, this one JSON output parser, we got JSON data. Okay, and with the help of pydantic output parser base model, we use, use cases is validated object. Okay, and comma separated list output parser, it is giving us list, simple list in output. Okay, so we use output parser here. Okay, that's why. Okay, what kind of output we want in str, in dictionary, in base model, and in list. Okay, so these are the output types. So here there are three, and there are different type of output parser. Okay, there are different type of output parser. Str output parser gives the simple text. Okay, simple text. And JSON output parser give the dictionary format. Okay, and here we have pydantic output parser gives the structure object, and comma separated list output parser gives the list format. Okay, so this is the here string output parser. This is the simple parser, it convert AI response into a plain string. We use it when we just need text output. Okay, and JSON output parser, this one, this convert output into a JSON format. So we will get dictionary like structure. Okay, and pydantic output parser, this one, this give strongly structure object. Okay, we define a schema first, then AI follow the structure. Okay, and comma separated output parser here, this convert output into a list. Item are separated by a comma, useful for generating the list. Okay, so so one in one line I'm going to say parser convert AI output into a usual format. Okay, without parser AI will give us raw text. Okay, with parser we got structured data from AI. Okay, so let's see how each parser work in a code. Okay, so first I'm going to write here. Now we will learn JSON output parser. Okay, by default AI give us text output, but in real application we need a structured data like JSON. JSON means data in key and value format. Okay, like dictionary. So we use JSON output parser to convert AI output into a Python dictionary. Okay, so I already have code, guys. I'm not going to write code. Okay, so I'm going to copy from here. Okay, so I use JSON output parser here from LangChain underscore core output parser. I'm going to import JSON output parser. Okay, that it will convert into a JSON keys and values. Okay, and this is our prompt, JSON underscore prompt. Okay, so here I pass chat prompt template dot form. Okay, JSON output parser and get the structure data back. So I use JSON prompt equals to chat prompt template, this is for prompt template, dot from message, this is the message. Here I pass the system message and human message. System message always is some response with valid JSON, and human message, inside the human message I pass give me a information about the person as a JSON with key, name, field, and achievement. Okay, okay, so we are forcing AI to always give JSON format output. Okay, here in the system message we are forcing AI to always give JSON format output, and in human message we ask AI to give the structured data from a person. Okay, person is a variable that will be replaced later. Okay, and here I'm going to create a LCELE chain. So here I mention this is our LCLE chain shell carry chain. This is our chain. Okay, LangChain expression language, LCEL chain. This is our LCEL chain. Okay, so here I pass JSON chain, and this is the variable name JSON chain. Okay, here I pass JSON from this one and LLM. Okay, and JSON output parser. Okay, I pass this prompt to the LLM, and LLM generate the JSON output parser result in a key and values. With the help of this, it will generate the output in a key and values. Okay, in JSON format. Okay, so here, prompt is created here. Okay, prompt is created here. Where is it? This one. Prompt is created here. It goes into the LLM, and or we can say we are sending input value for. Sorry, here prompt is created and it goes into the LLM. Okay, LLM here, and then output parser convert text into a Python dictionary. Okay, and now we are going to invoke this chain. So here I use invoke. Okay, so here I invoke this chain. Invoke means asking something. Okay, so result equals to I pass this JSON underscore chain dot invoke and ask the question. Here person is Alan Turing. Okay, here person के जगह मैंने ये नाम लिख दिया, इसको replace कर दिया. ठीक है. Now I'm going to print type of result. Okay, and print the result and result name access like a normal dictionary. Okay, so here this one, it's so, I mean it should be a class. Okay, class because JSON parser converted it. Okay, and this one print the full dictionary output with the help of print result. Okay, and here accessing dictionary like normal Python dictionary, we are extracting only name field here. Okay, यहाँ पर हम बस only name field access कर रहे हैं. I'm going to run this. So yes, you can see first you got this one type of result. Okay, it is giving us dictionary. Okay, and name is this Alam Matheson Turing. I already passed here this one. Okay, and field, inside the field I have computer science, mathematics and logic achievement, and it is giving us guys dictionary. Inside this we have list. This is our list. Okay, so this is our proper result, and it is going to extract here name. Okay, so this is the name only. Okay, these are the three results because I already print three thing here. Okay, now we have another thing. Okay, so here we ask AI for structured data. Okay, parse and convert response into a dictionary, so we can use it like normal Python object. Okay, so like filling a form. Okay, each field has a key and values, name, field, achievement, all structure. Okay, so without parser text output, and with parser dictionary JSON data. You can see here we have dictionary JSON data here. Okay, we have keys, values, keys, values. Okay, keys, inside this list we have values. Okay, so this is our data in a dictionary format. Now we have another point. Here, okay, now we will learn pydantic output parser. Okay, this is the most powerful output parser in a LangChain. Here we define the strict structure for AI output. Okay, so AI must follow our format exactly like a schema. So this is very useful in real world application like APIs and apps. Okay, so here I'm going to remove this. Okay, so here I'm going to import from LangChain underscore core output parser. I'm just using pydantic output parser. Okay, from pydantic I'm going to import base model and field. Okay guys, so I hope you already know about base model and fields. Okay, inside the field we need to define fields like greater than, larger, I mean whatever field we use. Okay, and base model I use for validate the data. Okay, data validation. Okay, or from typing I'm going to import list. Okay, so here after this I'm going to define a structure schema. So here defining the structure schema. So guys, this is our class. Define the what you want to the output look like. Okay, so class equals to movie review. Inside this I pass base model. Okay, and title should be string, and field equals to description movie title. Okay, and rating should be in float, is equals to field inside the description rating from 0 to 10. Okay, pros also in list, and it should be in list of string. Okay, and inside the field I pass description list of pros. Cons list of string field description list of cons. Summary should be in string field description one sentence summary. Okay guys, so these are the field. Title should be in string, you can't give in integer. Okay, rating should be in float, you can't provide it into a string or integer. ओके गाइस, तो यहाँ पर मूवी रिव्यू में क्या हो रहा है, हमें वैसा का वैसा डेटा देगा बेस मॉडल. अगर तुम गलत गलत चीज भरोगे, टाइटल अगर आप किसी और फील्ड में देखो, लाइक आपने इंटीजर दे दिया, तो ये ऑटोमेटिक एरर दे देगा. ओके, सो दैट्स वाई वी यूज पाइडेंटिक हेयर. समरी हमें किस में चाहिए, स्ट्रिंग में, हमें और दूसरा डेटा टाइप नहीं चाहिए. ओके, सो यहाँ पर समरी हमें वो स्ट्रिंग में देगा, अगर कोई आप और डालोगे तो वो एरर दे देगा. दैट्स इट. तो इसीलिए हम ये बेस मॉडल यूज करते हैं. क्या करता है, डेटा को, हमारा जो डेटा है डेटा वैलिडेट करता है करेक्ट फॉर्म में. ओके, it is going to convert our data into a valid form. Okay, so now you can see here title, this movie title is in string. Okay, float, this define rating as a decimal number, and this one pros, decimal pros as a list of string. Cons, it define the cons as a list of string. Okay, and summary, this is the final summary in one line. Okay, so here after this we have this parser equals to, I'm just creating parser here. Okay, parser equals to pydantic output parser. हमने बस ये वाला parser उठा के use कर लिया. Before I use this, now we are going to use this output parser here. Okay, so output parser, here I'm using output parser. We are telling LangChain here. We are telling LangChain AI must follow movie review structure. Okay, so here I pass pydantic underscore object movie review. Okay, we are telling LangChain AI must follow movie review structure. Okay, and here get format instruction. Okay, so get format instruction to include in the prompt print parser dot get format instruction. Okay, so this generate the structure instruction for AI. Get format instruction means this generate the instruction for AI, so it known exactly how to format output. ठीक है, and we print only first 300 character for preview. First 300 character for preview. We define a structure first here. Okay, we define this is our structure first. Okay, then AI must follow this rule. Okay, so output is always clean and predictable. Okay guys, so output should be formatted as JSON instance that conforms to the JSON schema follow. As an example for schema properties, this is our output. Title foo, okay, and description, this is a description list of string. Okay, in description we have list of string, and type array, an item. Okay, and the object equals to 2 for was. Okay, so guys, it is going to print parser dot get format and 300. We print only 300 character for preview. Okay, so here you can see example for the schema properties. Okay, title is foo, it is taking I title is foo, title is foo. Okay, and description a list of string. Okay, description equals to a list of string. Type array item, Okay, so after this, mm, so here, this is our, so here like a movie review form. Okay, so here like a movie review form, you cannot write anything randomly here, you must fill proper field only. Okay, so this is not just a text generation, this is the structure output generation. AI output equals to fixed structure schema based. Okay, so AI must follow that structure, so output is always clean and predictable. Hmm? So guys, it is giving us the answer. Property, this is the title, and this is the description. Type, error item, and require foo, and then object, this one. So parser dot get format instruction is just only giving three from, I mean only 300 character from starting. Okay, so I just finished JSON output parser and this one. You can see here in movie reviews, this is the class I use pyrentic output parser. Okay guys, but this one, this is not the final answer. This is just a rule for the AI. Okay, it tell the AI your response must be in JSON format following this structure. Okay, and you can see here the output should be formatted. Okay, the output should be formatted as a JSON instead that conform to the JSON schema flow. Okay, so as an example for the schema should be like this: AI must give answer in JSON format. Okay, and it must follow the given instruction or structure exactly. Okay, so you can see here from property, and here title, this one, title equals to foo. So there is a one field called the foo, this one, foo. It must be a list of string. Okay, it must be a list of string. So foo, like foo equals to like this, foo should be in dictionary, foo should be, foo should be like this. Array, why it is in capital? So foo should be like this, var, comma, like this for example. Okay, and corrected output example, foo contain a list of value. Okay, foo contain a list of values. Okay, so here this is just telling AI give the answer in a fixed JSON format, not random text. Okay, like giving a form to fill. Okay, you are telling what field are allowed and what type of data goes inside. Okay, so most important point, this is not the answer, this is the only format instruction from the AI. Okay, and it is also saying in description it should be a list of string. Okay, okay, and this is the only format instruction for the AI. Okay, so it define how AI should structure the JSON response. Okay, so it is just going to tell output should be in JSON format. This is not final output. Okay, this is the instruction AI give us. Okay, so it defined the how AI should structure its JSON response. Okay, okay, so it is not final answer. Okay, and here you are telling to AI what field are allowed and what type of data goes inside. Okay, we are going to tell like if somebody is used what kind of data allow and what kind of uh I mean type of data goes inside. Okay, so give answer in a fixed JSON format here and random text. I'm telling to AI, this just tell the AI. Okay, तो गाइस इसका मतलब यही है कि व्हाट काइंड ऑफ फील यू नीड टू फिल। ओके, आप मूवी रिव्यू कैसे फिल करोगे, किस टाइप के होने चाहिए, स्ट्रिंग में होनी चाहिए, रेटिंग किस टाइप से होनी चाहिए, फ्लोट में होनी चाहिए। तो यहाँ पर इंस्ट्रक्शन देने हैं एआई को, ठीक है, कि किस किस टाइप का कैसे कैसे डेटा होना चाहिए, ठीक है। और आप यूजर हो तो आप भी किस टाइप का डेटा किसी फॉर्म में फिल कर रहे हो वो भी आपको देखना पड़ेगा, आपको बताएगा ये। अगर आप गलत डालोगे तो एरर दे देगा, ठीक है। तो ये फाइनल आउटपुट, नॉट दिस इज नॉट अ फाइनल आउटपुट। ओके, सो गाइज अगर आपको ये समझ में नहीं आ रहा है, ओके, अगर आपको ये समझ में नहीं आ रहा है तो डोंट वरी इफ यू डोंट अंडरस्टैंड इट। ओके, सो डोंट वरी, you will understand when you learn pydantic. Okay, so everywhere we use pydantic in Python. In fast API also used pydantic, or we also have pydantic AI. Okay, I already uploaded pydantic AI videos. Okay, so you will definitely understand this. Okay, now I'm going to create, now we will combine the everything. Okay, so now we will use pydantic output parser here with LangChain. Okay, so now we will combine everything. So we will use pydantic output parser with the LangChain. Okay, we will use pydantic output parser with the LangChain. AI will review a movie but output will follow our strict structure. So we will get clean and structure movie review as Python object. Okay, so here you can see movie review. This is the prompt. Movie review equals to chat prompt template, and I use from message. Okay, and here I pass system message, you are a movie critic, and here I pass the format instruction, this one. Okay, so here we are telling AI to act like a movie critic. Here we are going to tell AI, okay, telling AI to act like a movie critic, and this is a this one. Okay, this one, and in we are going to tell AI to act like a movie critic and also follow the format instruction. Okay, schema rules. And here human review equals to movie review. So we pass movie name here, example inception. Okay, we can pass any movie name here. Okay, and here movie chain, movie equals to movie underscore chain equals to, I pass this movie prompt and I will give this prompt here inside the LLM, and LLM generate the answer. That's it. Okay, so here we created chain, movie underscore chain. Okay, prompt is created here and then send it to the LLM, and output parser, output is parsed into a pydantic object. Okay, okay, this one I use here, and now this parser I'm going to use here. Okay, so print output type here, I'm going to print output type, this one, review. Okay, so here review, what is the review? So I'm going to invoke chain here. Okay, I'm not going to print output at, okay, so here review equals to movie chain, this one, and I'm going to invoke, matlab asking something, movie name inception and format instruction pass dot get format instruction. Okay, so here we give movie name as an input, and here we give schema rule, so AI know output format. Okay, so I use this parse, this one. Okay, and I giving get underscore format underscore instruction. It's means we give schema rule, so AI know the output format. Okay, तो हमने यहाँ पर schema का rule दिया हुआ है, ये वाले rules. Okay, we are giving this rules here in the form of parser. Okay, so AI will know output format, what kind of output I want. Okay, so with the help of this parse output हमने ये दे दिया कि title हमारा, title should be in string, rating should be in float, pros in string, list of string, and cons also list of string, and summary is also string. Okay, तो हमने यहाँ with the help of parser दे दिया कि what kind of output format I want. Okay, with the help of this it will understand, AI know the output format. Okay, get format instruction. Okay, now I'm going to print here. Okay, so print review, it's a type. Okay, I'm going to print one by one. Arre, what happening here? My cell is not working. It is loading. Okay, so it is giving us type of review. So class of main dot movie review. Okay, so it is giving us this class movie review. Okay, and then I'm going to print these thing. Okay, movie title. Okay, so you can see here टाइटल इज इंसेप्शन. मैंने यहाँ पर पास किया था इंसेप्शन. मूवी टाइटल इज इंसेप्शन एंड रेटिंग इज 9.0 and 10. This is a real rating. Okay, pros, these are the pros. LLM generate this answer, guys. Okay, here you can see title equals to review the title. Okay, so it is giving us title, review of the title, movie title from structure output, and here rating. Okay, and here pros and review dot cons. ओके समरी. सो यहाँ पर ये सब चीज़ें यहाँ पर प्रिंट कर रहा है. कॉन्स दे दिया इसने. ओके एंड समरी. इंसेप्शन इज अ थ्रोट प्रोवोकिंग एंड विजुअली स्टनिंग sci-fi action film that explore the concept of shared dreaming. Okay, and pros, you can see mind blowing and visually stunning action sequence. Okay, and cons is some viewer may find the movie non-linear narrative and multiple plot thread confusing. Okay, so these are the summaries, cons, pros, and rating and title. So everything is going to print here. देखो guys, हमें यहाँ पर clear और structure output मिला. Title is in string, rating should be in float. Okay, pros also in a list of string. You can see here हमारे पास list है. इन लिस्ट में हमें एक एक चीज यहाँ पर देखें. वी हैव लिस्ट ऑफ pros. Okay, and this is in string. You can see here pros, what we have, list of string. Okay, so first index, second index of list, third index. So we have list of pros and also we have list of cons. Okay, with the comma separated way. Okay, and this is the summary. Okay, so after this we have another. So here we send movie name to AI. Here we send movie name to the AI. Okay, insertion. We send movie name to the AI and AI review it and parse, convert response into a structured Python object. Okay, and like for example, like filling a movie review form. Okay, like a filling a movie review form, every field is fixed. AI cannot break structure. Okay, so we are not getting text here, we are getting a Python object. Okay, so this is our proper answer. Now we have another. So we are not getting text, we are getting Python object. Okay, and now we have another prompt, comma separated. Okay, this is the last one. So here AI response in structure Python object. Okay, so now we will learn comma separated list output parser. Okay, this one I already used this one, so that's why I haven't mentioned this. I used here JSON output parser, pydantic output parser, and now I'm going to use comma separated list output parser. Okay, so here we use comma separated output parser. Okay, so sometime we want AI to return a list. Okay, like a 5 item 10 tool or name. Okay, instead of text we convert output into a Python list automatically. Okay, so here I'm going to write code. I'm going to import something. Actually I'm going to copy. Okay, so you can see here from LangChain underscore core output parser. Guys, this is the inbuilt. Okay, I'm going to import comma separated list output parser. Okay, I'm going to import list output parser that we can use inside this. Okay, so list output parser equals to comma separated parser. Okay, and here I create one prompt. इसकी हेल्प से हम कॉमा सेपरेटेड आउटपुट पार्सर का हम लोग अपनी कोड में यूज कर सकेंगे. सो दैट्स व्हाई आई इंपोर्ट दीज टू थिंग्स. ओके, दिस इज द लिस्ट पार्सर इक्वल्स टू कॉमा सेपरेटेड आउटपुट पार्सर. कि आप कौन सा आउटपुट पार्सर यहाँ पर यूज कर रहे हो, दिस वन. okay, here this is these are the I mean here this is for print prompt list underscore prompt. I pass chat prompt template dot from message. Here I pass human message list of 5 category formatted instruction. Okay, okay. Now after this one this parser convert comma separated text into a Python list. Okay, comma separated parser into a Python list. 1 minute. Okay, so this means list parser equals to comma separated output parser. This parser convert comma separated text into a list. Should I mention here? Yes, I can mention here. This convert comma separate text into Python list. Okay, and this is the prompt. Okay, so here this is a human message. P ask AI to give the 5 item. Okay, 5 item of a category. For example, 5 item of category and format instruction. I use format instruction. This tell AI to how output should look. Okay, ये proper format के लिए use होता है. This tell AI how output format look. Okay, then after this I'm going to create chain here. Okay, so after this we have this chain. I'm going to mention here chain. Okay, so chain, here you can see list underscore chain. Here I pass this list prompt of list, and here LLM and list parser. This one list parser. Okay, so here why we use this. Okay, so this one list this one, guys, this is only normal chain. Okay, prompt is created here. Okay, and we send this prompt to the LLM and output converted to the Python list with the help of list parser. Okay, so now we are going to invoke the chain. So here we are going to invoke result equals to LLM underscore chain dot invoke category equals to popular Python library. Okay, here I give category. Okay, so here I give the categories. Python category equals to Python libraries, and format instruction list underscore parser get format instruction. Okay, so after this I mean here this one is the we are asking for Python library list, and this tell AI to return the comma separated format. Okay, and now I'm going to print output. So here print type result list for I an item in enumerate result comma 1. Print here this is for number and item dot strip. So you can see here. Okay, so this is the type of result, that is list. Okay, and here I an item. So I means number 1 2 3 4 5, and number item means it is giving us 5 category. Okay, NumPy, pandas, matplotlib, scikit-learn, and request. Okay, these are 5 categories in Python. Okay, popular libraries in Python. These are the categories. Okay, guys, so here like giving a shopping list, each item is separated by the comma. Here you can see this is also separated, here separated, this is also separated. Okay, so without parser string it is giving us a string, and with parser Python list. Okay, now here are 5 popular libraries: NumPy, pandas, request, scikit-learn, and matplotlib. It is giving if you run multiple time, it is giving answer different things. Okay, you can check here. Okay, so this is our answer. Text equals to list of conversation automatically. Now we move here memory and conversation history. Okay, so now you can see here I'm going to start number 6, memory and conversation history. So now we will learn memory in LangChain. Okay, so till now our AI was stateless. Okay, it does not remember anything. Okay, every question was treated as new. Okay, but in real chatbot we need memory, so AI can remember past conversation. Okay, so memory means storing previous message. Memory means storing previous message, so AI can give better and connected answer. Okay, okay, so like chatting with a friend. If you have friend, then you will chat your friend on WhatsApp. Okay, like chatting. Okay, so like chatting with a friend, if you say your name once. Okay, if you say your name once, they remember it later. Okay, so without memory, AI forget everything. Okay, and with memory, AI remember conversation. Okay, so we store message in a list. Okay, so you can see here, memory versus conversation history. Memory allow you chat what to remember previous message, means chat history. Okay, so modern LangChain memory approach, we are going to use 4 approach. Okay, first is manual history, store message in a Python list. Okay, so in manual history, we store message in a list, simple and easy to understand. Okay, and chat message history. Okay, chat message history, LangChain message store. Okay, so we store message in a what? We store message here in LangChain. Sorry, so chat message history, LangChain give the built-in memory storage. Okay, that is chat message history, this is built-in. Okay, LangChain give us built-in memory storage, so we don't need to store manually. Okay, so with the help of this, LangChain store the message. LangChain message store here with the help of built-in library chat message history. And we have another third one is runnable with message history. Okay, so this automatically handle memory. This one runnable with message history, this automatic handle the memory. Okay, automatic history management here, so best for real application. And we have fourth one, that is summary memory. Summarize old message to save the tokens. Okay, summarize old message to save the tokens. Okay, so old message are summarized, so memory use less tokens here. Old message summarized, so memory use less tokens here. Okay, so now let's understand what this one memory and conversation history. Okay, so here you can see from LangChain underscore core dot message, I'm going to import human message and AI message. Okay, so now we will implement memory manually. Okay, we will store conversation in a list and pass that history to the model every time. Okay, so AI can remember the previous message here. Okay, so I import here human message and AI message. Okay, so now I'm going to create one prompt, chat prompt. Here I need to chat prompt. Okay, so this is the prompt, chat prompt. Here I use chat prompt template, and here dot from underscore message. Inside this message I pass this system message. Okay, system message tell AI to behave like assistant and remember chat. Okay, so inside system message I'm going to pass here, you are a helpful assistant and remember the conversation. That's it. Okay, and here message holder equals to variable name history. Okay, so here this is the variable name history, so you are a helpful assistant, remember the conversation, and placeholder history. Okay, and human equals to, we give here input. Okay, so message placeholder, here I pass the variable equals to history. This is a very important, it will insert past history here dynamically. Okay, past history of your chat. Okay, so here it will insert past history here dynamically with the help of this. Okay, and we have current user input comes here. So human equals to input, and here I have created one chain. This one chain equals to this prompt, chat prompt, and this prompt I'm sending here LLM, and LLM generate the output in string because I use str output parser. Okay, so here prompt goes here, and we can send this prompt into LLM, and LLM convert output into a string. That's it. Now we are going to store the conversation. Okay, so with here I'm going to store our conversation. Array, what happening here? So yes, we are going to store our conversation here. I'm going to copy and paste it here. Okay, so this will store the conversation. This list will store all the past message. History equals to list. Okay, now I'm going to create chat function. This is the chat function. Okay, so this function handle one message at a time. Okay, this function handle one message at a time. Here I pass the user input. Okay, and here response. This function handle one message at a time, and response equals to chat.invoke. Invoke means asking something. Here I pass the input. Inside the input I have user underscore input, and history equals to history, past history, this one. Okay, so here input equals to user input, and history means passing full conversation history. Previous में आपने जो बात करी है conversation history, then I need to pass it here. Okay, then I need to put here human message. So in history में मैंने क्या किया, history dot append human message और content equals to user input. तो यहाँ पर इस line, what does it mean of this line? Okay, so here store user message. Okay, here we are going to store user message. Okay, in history we are going to store user message. Okay, and history dot append AI message content equals to response. AI message means जो AI हमें मैसेज दे रहा है, ठीक है, जो रिस्पॉन्स जनरेट करता है वो, ठीक है। तो हम यहाँ पर क्या, तो हमने यहाँ पर ह्यूमन के जो पुराने मैसेज है, ओल्ड मैसेज ह्यूमन के, वो हमने हिस्ट्री में डाल दिए, और हमने जो क्या कर दिया, हिस्ट्री में AI मैसेज भी डाल दिया जो AI ने रिस्पॉन्स जनरेट किया, ठीक है। सो हियर वी आर गोइंग टू एड ह्यूमन मैसेज। अगर ह्यूमन अभी मैसेज सेंड कर रहा है वो हिस्ट्री में जाके ऐड हो जाएगा। ओके, सो वी आर गोइंग टू ऐड ह्यूमन मैसेज इनटू हिस्ट्री, एंड जो भी रिस्पॉन्स दे रहा है ह्यूमन मैसेज का AI, ओके, देन वी ऑल्सो अपेंड दिस AI मैसेज एंड ह्यूमन इनसाइड द हिस्ट्री इन दिस लिस्ट। ओके, and here it will return the response, return the AI output here. Okay, so here AI save the response in a history, and here AI save the input, human input in the history, user input, whatever. Okay, now we are going to print everything. So first I'm going to print these two. Okay, one by one we can print everything. Okay, first I'm going to print you. Hey, my name is Nidhi and I love Python. And this is the answer by chatbot. Hey, my name is Nidhi and I love the Python. So here, this is my answer. I'm saying to chatbot, hey, my name is Nidhi, I'm learning Python. Bot also said that this is the answer of bot. Okay, so here in bot I pass the chat. Okay, inside the chat I'm giving this. Okay, so nice to meet you Nidhi, it's great to hear that you love the Python. Okay, so guys, यहाँ पर मैंने ये जो ए वाली chat थी ना, ये वाली chat, I'm just passing this chat here. Chat, my name is Nidhi and I love Python. So bot is giving answer, hi Nidhi, nice to meet you. Nidhi, it's great to hear that you love Python. Python is fantastic language for beginner and experienced developer. Okay, so this is answer. This is input given by me, and this is the answer generated by the AI. This is called the AI message, and this is called the human message. Okay, now I have these two things. You means me. Okay, now you ask, what programming language do I love? Okay, so chatbot say, what programming language do I love? Okay, so यहाँ पर ये अपेंड कर रहा, बार बार हिस्ट्री में ऐड करते जा रहा है। अब यहाँ पर देखेंगे हमने उससे दोबारा पूछा, what programming language I love. मैंने उससे पूछा बोर्ड से, ठीक है। सो बोर्ड में मैंने यहाँ पर चैट पास किया, what programming language do I love. I pass here this chat here in board, what programming language do I love. So it is saying what. So this is the response, human questions answer. Okay, so this is the answer. Okay, so this is the question asked by human, what programming language do I love. Okay, in human message, And AI response, you mentioned earlier that you love Python. Okay, this sound right to you, Nidhi? Does that sound right to you, Nidhi? Okay, so इसने आंसर दिया कि आपको पाइथन पसंद है. Does this that sound right to you, Nidhi? Okay, so यहाँ पर इसने रिमेंबर कर लिया था पहले ही. It is remember previously. It was remember everything previously. Okay, and then give you the answer like this. Okay, and now I'm going to ask another question to both. What is my name? Okay, this is the another question. Okay, what was my name? And here also I pass in chat. So guys, this is called the manual history. Okay, here हम यहाँ पर chat में भी बोट को दे रहे हैं कि यहाँ पर दो दो चीज दो दो बार दे रहे हैं. यहाँ this is question asked by me and this is the chat boat. बोट for बोट के लिए भी हम यहाँ पर दे रहे हैं कि जो ये चीज chat करके हमने यहाँ पर डाला है तो हमने यहाँ पर दिया. So it is saying this one. What is my name? So it is saying your name is Nidhi. We just started our conversation and you introduce yourself with that name. ठीक है, तो उसको याद हो गया कि मेरा नाम निधि है. सो गाय दिस इज द मैनुअल कन्वर्सेशन, मैनुअल हिस्ट्री. ठीक है, हम वी आर जस्ट यूजिंग हेयर मैनुअल हिस्ट्री. वी आर स्टोरिंग एवरीथिंग हेयर, ह्यूमन हिस्ट्री, ह्यूमन मैसेज हिस्ट्री एंड एआई मैसेज हिस्ट्री. तो यहाँ पर रिस्पॉन्स में भी सब चीज़ें स्टोर हो रही है और जो ह्यूमन रिस्पॉन्स एंड सॉरी ह्यूमन मैसेज एंड एआई रिस्पॉन्स, एवरीथिंग इज स्टोर हियर इन अ history list. Okay, and then it will remember everything and give you the answer like this. Okay, it is giving us everything and remember every history. Okay, so we store message in a list here. Okay, and then send that list every time. Okay, and then send that list every time. Okay, with the help of this I use this chat. You can see here chat. Okay, we store message in a list in history. Okay, history.append human message, history.append AI message. हमने सारे यहाँ पर स्टोर कर दिए. with the help of this function I use this chat. Okay, it will generate it will remember conversation. Okay, so like saving chat in a WhatsApp, you can scroll and see old message. Okay, memory is not automatic here, so we are manually storing and passing it. Okay, so store history, passing history, and AI remember everything. Okay, so now after this I have another memory. Okay, so now we will learn automatic memory using runnable message history. Okay, now we are going to learn automatic memory using runnable history. So we use LangChain's built-in method. Okay, runnable memory. So here runnable with message history. Okay, so in previous example we store memory manually here. Okay, but here LangChain will handle memory automatically. Okay, also we can chain multiple user with different session. Okay, so here I use actually I have code here. This is very long. Okay, no problem. This is approach 1. Now we have approach 2. Here I'm going to use inbuilt. Okay, okay, so you can see here this is our approach to runnable with message history, product ready memory. Here LangChain is automatically remember memories. Okay, so here LangChain will handle memory automatically, and also we can manage multiple user with different sessions. Okay, so here first store for multiple users. Okay, so I create a store equals to dictionary that we can store different session like different user and session IDs, and session IDs equals to chat message history. Okay, so here dictionary, this is the dictionary to store memory for each user. Sorry, so here this is the dictionary to store the memory for each user. Okay, and format equals to session ID chat message history. This is the format. Okay, तो यहाँ पर हर यूजर का मेमोरी जो स्टोर होगा हिस्ट्री, उसका फॉर्मेट रहेगा सेशन आईडी एंड चैट मैसेज हिस्ट्री। ओके, सेशन आईडी के साथ उसका चैट हिस्ट्री स्टोर करेंगे। वी विल स्टोर chat message history with the session ID. Okay, and this is the function def get session underscore history. So this function return chat history for a user. Okay, here I pass session ID and session ID as a parameter. Here it should be in string. Okay, and here output should be in chat message history. Okay, so here this function return the chat history for a user. This function return the chat history for the user. Okay, so you can see here if session id not in store here. Okay, so it will store session id and their chat history. Okay, and return the store id here. Okay, if user is new, create a new memory for user. Okay, so this function are used for return the chat history. Okay, for a user. Okay, if user is new. Okay, if session id is not in store, or if user is new, then it will store session id with chat history inside this store. Okay, store session id. Okay, so it return the user's memory here. Okay, and now we are going to create prompt. So here I'm going to create one prompt. Okay, so what is the prompt? This one is prompt. One minute, we have multiple conversations. 1, 2, 3, 4, 5. Use session config user 1, config user 2. Okay, we are going to use from here. So here I'm going to create prompts. Alright, this one prompt. Okay, so here I create one prompt equals to chat prompt template dot form message. Okay, here I pass system message, you are a helpful assistant, and in placeholder memory I pass the history variable name equals to history as a memory here. Okay, so this is a AI behavior system. You are this is the system message. This is I'm giving instruction to AI, or we can say AI behavior. Okay, and here I pass placeholder, so past conversation will be inserted here automatically. Okay, so message placeholder variable name equals to history, so past conversation will be inserted here automatically, and human equals to input, so current user message, this one. Okay, and here I create this chain, base chain equals to I pass this prompt, and this prompt I'm going to send to the LLM generate the output in a string. Okay, okay, so now this is the basic pipeline. Okay, prompt is going to send here in LLM. We are sending this prompt into the LLM and it will generate the answer. Okay, text output. Okay, now we are wrap with memory history management. Okay, so here add automatic memory. Here we are just going to add automatic memory. Should I mention here add automatic memory? Okay, chat underscore with underscore history. I use runnable with message history. Okay, this is the inbuilt memory management process. Here I pass this base chain. Okay, इसको क्या क्या रिमेंबर करना, ठीक है. बेस चेन आई पास दिस बेस चेन, इनसाइड दिस आई prompt LLM and output parser. Okay, input message key equals to input and history message key equals to history. So this is the original chain, base chain. Okay, and this one get session history function to fetch the memory. Okay, get this function for fetch the memory, and input message key equals to input, so where user input come from, and history message key equals to where history is injected. Okay, so after this I'm going to create a different users. Okay, user 1 or user 2. So here I have different users. Okay, so use session id to track the different conversation. Okay, so config user 1, here I pass the configuration. Okay, inside this I pass session id. Okay, session id and username user alias. Okay, I'm already given here session id. Okay, so here we have different user id for alias. Okay, so this is the user id, session id for user alias. Okay, unique id for alias, session id, this may be unique, this should be unique id for alias user. Okay, and we have second user config user 2. Okay, I pass here configurable. I'm going to configure this, so it has another unique session id, and for username is bob. Okay, unique id for bob. Okay, so here after this alias conversation. Okay, so now we have alias conversation. This one, this is for alias. So we have this alias conversation here. Okay, so alias conversation means alias user asks something. Okay, input, I am alias, I like the cat. Okay, I pass config equals to this config user 1. Okay, for configuration guys. Okay, so here I pass the config user 1. Okay, and print alias 1 and r1, I pass this. So I'm going to say, I'm going to print this. So it is saying alias 1, hello alias, this is the AI message. Okay, hello alias, it's nice to meet you, cat are lovely creature, aren't they? So do you have cat at home, or are you thinking of getting one? Okay, so this is the answer generated by the AI. Okay, so now we are going to use bob conversation. This is the conversation asked by the doing by the bob. Okay, so bob asking, this is the second user, config user, and we are going to configure gravel here. Okay, so here r2 equals to chat message history. I use this chat message history, and inside this I'm going to ask invoke with the help of invoke. Input, I am bob, I like dog, and config equals to config user equals to 2. Okay, print verb 2, and here I pass r2. Okay, so here it is giving answer for verb 2, verb 1 also. Nice to meet you, bob, dogs are wonderful companion, aren't they? Okay, what kind of dogs do you like? Do you have a favorite breed, or do you enjoy all type of dog? Okay, so this is the answer generated by the AI. This is, guys, this is the AI message. Okay, now I'm again asking alias asking again. Okay, so this is the question asked by alias. Okay, alias asked again, so remember the like cats. Okay, so r3 equals to chat history. I'm passing this chat history. Okay, and invoke, with the help of invoke I'm going to ask input, what pet do I like. मैंने पूछा, if I'm alias, then I'm asking what pet do I like to AI. पहले मैंने AI को बताया कि मैं cat को पसंद करती हूँ. First I give message to AI in input that I like cat. Okay, now I'm asking what kind of, what pet do I like. So I'm asking this question to AI here with the help of this r3 equals to chat with history. I'm going to use this history. Okay, dot invoke input and ask what pet I like. Okay, and config equals to config user 1. I pass this one, user 1. Okay, print alias 2 and r3 here. So guys, this is the answer. r3, you like cats. It is just giving us you like cats. Okay, now Bob again asked the question. So guys, you can see here AI remember history with the help of this runnable. Okay, it is like automatic remembering history or memory. Okay, now Bob asked again. Okay, so Bob asked should remember he liked dog. Okay, so r4 equals to chat with history. I pass this chat with history, this one. Okay, and here I invoke input what pet do I like, and config equals to config user 2, because we are going to ask for Bob. Okay, and user 2 is Bob, so I pass verb 2 and I pass r4. Okay, so it is giving us answer. What kind of, oh, do you mention earlier that you like dog? Okay, you mentioned earlier that you like dog. Okay guys, so this answer generated by AI. So these are the AI messages. So you can see here everything remembered by AI with the help of runnable with message history. Okay, So this is my I mean this is the another kind of memory. So LangChain handle in internally. Okay, we can use this library runnable with message history. We can remember history with the help of runnable with history. Okay. Okay, so we do not store memory manually here. LangChain store it automatically. Each user has separate memory. Here you can see each user has separate memory. User 1 and user 2 both have different memory, and Alice has different memory. Okay, so like different WhatsApp chat, each person has separate conversation. Okay, and session ID is very important. It keeps our conversation separate. Okay, that's why I use here session ID. Okay, so automatically memory with multiple user support. Okay, so now after this I'm going to move here. So now we will learn window memory. In this, we do not send full history. We do not send full history. We only send last few messages. Okay, this will help to save the tokens and improve the performance. Window memory. Okay, so maybe I have code. Yes, this one. I'm going to remove this. I already finished this one. Okay, so third is window. Okay, so I'm going to copy these 4 5 line. Okay guys, this is the third approach. Window memory, only keep last message. Okay, so यहाँ पर मैं क्या करूँगी? What I'm going to do here, in this we do not send full history. We only send last few messages here. Okay, we only send last few messages. This help save the token and improve the performance. Okay, so I'm going to import in memory chat message history. Okay, in memory chat message history. Okay, with the help of this we can give only last message, not giving full history. Okay, so from LangChain underscore core I use chat history and import in memory chat message history. Okay, and window size equals to 4. So keep last 4 messages. Okay, to exchange. Or here history, this one. So here you can see here window size, so we keep only for last 4 messages, 2 for user and 2 for AI. Okay, so should I mention here, we can store only 4 messages here, 2 for user or 2 for AI, 2 user message and 2 AI message. Okay, okay, and we have history underscore window. So here we keep only history here. So this is store all messages, full history. Okay, so here I need to mention store full message history or message. Store full message or full message history. Okay, full नहीं लिखना है, should mention here store all messages. Okay, full history. And here this is the function name. Okay, so here I'm going to create chat function with window. Okay, so this one chat underscore window, I pass here user input as a parameter. Okay, get only recent message. With the help of we get only recent message, recent equals to history underscore window, I use this one, and here I use -1. Okay, means last message, last 4 message. Okay, सो यार हम यहाँ पर क्या कर रहे हैं, रिसेंट जो लास्ट मैसेज है वो यहाँ पर विंडो में डाल दे रहे हैं. ओके, सो ओनली पास लास्ट मैसेज, लास्ट विंडो साइज मैसेज हियर. ओके, रिसेंट इक्वल्स टू हिस्ट्री विंडो. ओके, हिस्ट्री अंडरस्कोर विंडो, दिस वन आई पास हियर माइनस विंडो size. Okay, so I use here minus window size and here last message. Okay, so I'll take minus, last 4 messages with the help of this. Okay, it is like backward. Minus window size, so like if you use it is giving us after colon we don't have anything, means last message. Okay, so it is going to take minus I mean, with the help of minus we are going to take last four message. Okay, and here take last n message only in window. Okay, and response means here I am going to call the LLM with limited history. Response equals to chain dot invoke. Okay, and here I pass the user input and history, recent history. Okay, so only recent message are passed to the AI. User input here and recent history. Okay, okay, not everything. So after this, add user input to the history and store. Here we have another line. Store AI message. So here I store history. I store append the human message inside this history window. So here history window dot append human message. Okay, add user input to the history inside this content equals to user input, and history underscore window I'm going to append AI message. I'm going to store AI message also here in history window and return the response here. So add AI response to the history and add user input to the history. Okay, and return the AI reply here. Okay, so after this we can print for demo. So I'm going to print one by one. Array. Okay guys, so you can see here print window memory demo. Okay, so here this is for like display output. Okay, and here I use chat underscore memory, this function. Okay, and here I use my favorite color is blue, and I giving here as a user input. Okay, I live in Mumbai, and I also give them one message. I work as a data science. Okay, so AI learn your favorite color with the help of this, and AI learn that you also uh, live in Mumbai. Okay, and AI learn more history about you. I work as a data science, so AI also learned this message. Okay, this history. Okay, so more history added. Okay, here. Now you can see after window slide might forget favorite color. Okay, so here result equals to chat history. I chat window. Okay, and again I'm going to add more. What is my favorite color here? Okay, I'm going to add more. What is my favorite color? Okay, so here you can see here I print the result, this one. Okay, this is I'm going to ask the question, what is my favorite color to AI. Okay, and it is going to print total message stored length of window underscore sorry हिस्ट्री अंडरस्कोर विंडो कितने मैसेज हमने स्टोर किए उसकी लेंथ बताएगी यहाँ पर हाउ मेनी मैसेज आई स्टोर हियर inside this okay, so it is giving me length and print the use in last call. So window size, it is giving us window size here. Okay, so total message in a full history, the help of this it is going to print, and window size only these messages we are used. Okay, so here, so you can see here I got output window memory demo. Okay, so I give chat underscore window my favorite color and कहाँ रहती हूँ मैं, where do I live and where do I work. Okay, I give this to the chat window, this. Okay, then I also print the result, what is my favorite color. So window memory demo, I don't have any instruction about your favorite color. We just started our conversation and we only discussed that you live in Mumbai. Okay, so it is said that it is remember only something, maybe it is going to forget. Okay, it is forget your favorite color. Okay, but it is giving us answer that we just started our conversation and only discuss about you live in Mumbai and work as a data science. Okay, so after windows light might forget favorite color. Okay, so it is your, like it is going to forget your favorite color, but it remember where do you live and you are a data science. If you would like to share your favorite color, I would be happy chat with you about it. Okay, so here it is giving us it is forget this message, and this is print here. With the help of this, it is going to print your result. May or may not remember, depend on window. Okay, so it is depend on window. Sometime it will be remember, sometime it will not remember. Okay, so total message store, it is going to store 8 message. Okay, 2 user message and 2 AI message only. So that's why it is only remember 2 message of your. Okay, your, it is remember only 2 message of your, 2 last message and 2 last message of AI. So it can only remember only 4 message used in last call, that is 4. हमने ऑलरेडी मेंशन किया यहाँ पर कि वो 4 मैसेज ही रिमेंबर कर सकता है विंडो के, ठीक है, 2 मैसेज फ्रॉम यूजर और 2 मैसेज फ्रॉम एआई. ओके, तो इसलिए यहाँ पर लास्ट मैसेज जो था हमारा वो भूल गया, व्हाट इज योर फेवरेट कलर. ओके, सो वी कीप ओनली रिसेंट मैसेज, ओल्ड मैसेज आर इग्नोर्ड. सो मेमोरी इज लिमिटेड हेयर, बिकॉज हमने यहाँ पर मेमोरी लिमिटेड दी है. ओके, but only last few messages are used and use recent history only to save the tokens. ठीक है. So here you can see, now we are going to move here 7. Okay, module 7, document loader and text splitter. Before we go, before we can do rag, we need to do this document loader and text splitter. Okay, so now before building a rag, we need to understand 2 very important steps. First is we load the document. Okay, so first is we load the document from various resources. Okay, and then second, we split document into a small chunks. Okay, I will tell you what is chunk. Okay, don't worry. So load the document like PDF, text file or website. Okay, split document, break into a small chunks. Okay, first is load the document, then second is split the document in small piece of chunk, like, okay, small piece of chunk. Okay, and store chunks later use in a search. Okay, then we store chunks, okay, later use in search. Okay, so why we use splitting here? LLM have limited context window. We split document into a small chunks. Okay, we can't send whole document at a time at once. Okay, so we have limited context window. Okay, so we split document into a small chunks, store them. Okay, and retrieve only the relevant chunk at query time. Okay, so first we need to load document and then split and then store. Okay, and then retrieve. Okay, so imagine you give a full book to AI cannot read the whole book in one go. Okay, so we break the book into small parts. Okay, then when user ask the question, we only send the relevant part to the AI. Okay, that's it. So here we split the we load the document and split the document. Okay, because LLM cannot read very big data at once, so that's why we need to split into a small chunks. Okay, so I already give one example that you give AI to you give a full book to AI, but AI cannot read this whole book at once. Okay, so we break the book into small parts and then user ask the question, we only send the relevant part to the AI. Okay, so it's like a Google does not search entire internet every time. Okay, it find only relevant pages. Okay, so same way we give only relevant chunk to the AI. Okay, so here we use document loader. Okay, so we convert first document object. LangChain work with the document format and loader convert raw file, structured document. And core understanding of this, we have one file and then we load with the help of loader. Okay, we have one file and we can use a load and document and ready for splitting. Okay, one line summary, we can use text loader, load file into a LangChain document format. Okay, wait a minute. Okay, so here so here maybe I have these lines. No, I don't have, no problem. Okay, so first we need to load the PDF file like text, website, whatever we have in documents. Okay, like this. Okay, then break into small chunks and then use in a search. Okay, Okay, so LLM has limited context window, limited context window. Okay, for example, model can read only few thousand words. If your document is very big, it will fail. So be split into a small chunks. Load, we need to load the document and split and then store and retrieve. Okay guys, so this is the process. Okay, so without splitting, model will respond slowly. Okay, and it costs more. I mean, it may be expensive and less accurate. Or with splitting, fast, cheap, it will be fast and cheap and more accurate. Okay, now let's see how we actually load and split document using LangChain. Okay, so first we are going to build something here. Okay, so now we will learn how to load the document in LangChain. Okay, we will start with a simple text file. Okay, later we will use different file. Later some concept will work for PDF and website etc. Okay, so later same concept will work for PDF and website etc. Okay, so here I use text loader to load the text document. Okay, text loader load file into a LangChain document format. Okay, so I use LangChain underscore community dot document loader. With the help of this we can load text loader. Okay, and here I give just simple text. Okay, so create a simple text file to load. Okay, so guys, this is the simple text I am giving here. LangChain is a framework for developing application powered by the large language model. It enables the application that are context aware, cannot a language model to solve. Okay guys, so this is the text I am giving here. I'm not going to read everything. Okay, I just giving the main component of LangChain are model, prompt, chain, memory, agent and retrieval. Okay, so everything you already know. Okay, retrieval means interface for fetching the relevant document. Okay, so this is the text I am giving here as a document. Okay, मतलब मैंने यहाँ पर कुछ text दिया as a document to the LangChain by using this library text loader. Okay, so here what I'm going to do. After this I'm going to write sample file here. Okay, with open sample doc.test wsl f dot write sample text. Okay, so here here open a file in write mode. It is going to open the file in write mode. Okay, and write our text info. Okay, and write our text info file here. Okay, and here load the document. It is going to load the document. Loader equals to text loader. I'm going to use this text loader. Okay, and inside this I pass this sample doc dot text and encoding utf-8. So it means create a loader. Okay, tell the path of the file. Okay, with the help of encoding we will use it for text file. Okay, that it will read properly. And doc equals to loader dot load. So load the file and return the list of document. Load the file and return the list of document. And here this is the output. Print loaded, length of document. Okay, and type of document. Okay, so here here load the file. This means load the file and return the list of document. Okay, and this one usually one file equals to one document. Okay, so it is giving us length. Okay, document type, it is giving us type of document, LangChain document object. Okay, and here you can see content preview doc 0. So first 100 character, it is going to show the 100 character of first document. Document 0 means first document and it's 100 character from 0 to 100. Okay, and metadata means here extra information like file path it is giving us. Okay, so here I'm going to run this. So guys, you can see here it is saying loaded document 1. Okay, loaded document 1, its length is 1. Okay, document type LangChain code document base document. Okay, this one I use this library from here. Okay, and here content preview, LangChain is a framework for developing application powered by LangChain model. Okay, so this is the content. Okay, and here it is giving us 100 word. Okay, previous LangChain is a framework for developing application powered by the LLM. Okay, and it is like it is giving a preview, this one. Okay, and these are the metadata, source and sample doc equals to text.txt. Okay, and you can see here I got this file here, sample.txt. I got everything here. Okay, I already said that it is going to read this Okay, read file, open the file in sample underscore doc.txt. ओके, इसने क्या किया, ये जो टेक्स्ट था इसको ये इसमें डाला sample डॉट टेक्स्ट में और उसको पढ़ा. ओके, ओपन करके उसको पढ़ा, and then it is going to print everything. Document length 1. Okay, what we have in document. Okay, and extra information, metadata, source and file name. Okay, so here after this I'm going to load PDF loader here. I'm going to load PDF with the help of PDF loader. Okay guys, so loader converted into raw file into a structured document here. और फाइल हमने यहाँ पर लोडर थ्रू उसमें हमने उसको प्रॉपर डॉक्यूमेंट बनाया, उसको पढ़ा, रीड किया और देन यहाँ पर हमें आंसर मिला. ओके, सो नो हियर PDF loader notes. Okay, so now we will load PDF file in real project. Most data come from PDF. LangChain make it very easy to read the PDF file. Maybe I don't have PDF file, guys. So guys, I don't have PDF file, but I can show you like this. Okay. So PDF loader. PDF is broken into a small page. Okay, I'm going to use PDF loader, but it will load PDF and broke into a small pages. Each page become one document. Okay, like a book, each page is treated separately. Okay, an important question, one PDF equals to many document. Okay, each page equals to one document. This is why this is important. Later we will split each page into smaller chunk. Okay, and we will store and search efficiently. Okay, so PDF convert into a multiple pages and then split into a small documents. Okay, small chunks and documents. Okay, so from LangChain.community, document.loader, import py PDF loader. Okay, so with the help of this we can load the PDF file. Okay, so here PDF loader load and split the PDF page automatically. Okay, so you can uncomment here. Okay, and use your PDF file. Okay, so here loader equals to py PDF loader, and here you can put your document name. Okay, what you have PDF. Okay, what kind of PDF you have and what is the name of your PDF. Okay, and page equals to load the page, loader.load. Okay, so each page is in a document, it will load. Okay, and print the loaded and length of pages. Okay, and print the first page. Okay, first page and character, I mean 100 character only. Page content, print the 2000 character, not sorry 200 character. Okay, so with the help of this we can upload the we can load our PDF. Okay, we can load our PDF with the help of this, and we can each page is a document here. Okay, and print the length of document and print the content from first page. Okay, print the py PDF loader using this one. Okay, and guys, you can use this. Okay, and uncomment this. I'm not going to write everything. Okay, now we are going to use web loader. Okay, so here we load data directly from the website. Okay, then convert into a document format. Okay, so here 1 minute. Okay, now we will load the data from the website. This is a very useful because we can give live internet data to our AI. For example, blog, documents and article. Okay, so core idea of हम have a website लेंगे. We are going to take one website URL and then we need to use HTML and clean text, and it will create the documents. Okay, so why splitting is needed? We break big document into small parts. Okay, like copy paste from the website but done automatically by the code. Okay, it is like copy paste from website, but we can do it with the help of code also. Why BS4 is used here? I use BS4. So website has a lots of nodes like ads, menus and buttons, so we extract only useful content with the help of BS4. And common issue, if internet is not working, it will fail. Okay, so that's why we use try except. Okay, website loader, you can see here, load the website and clean the content, convert into a document. Okay, now we will split the document into small chunks. Okay, so here this is a very useful because we can give live internet data to our AI. Okay, so here I'm going to use web loader. Okay, so you can see here. Okay, I import OS, I import BS4 beautiful useful SOAP helper for parsing HTML selectively. Guys, it is used for scraping. Okay, then I use this one, os.environment. Here I pass the user agent, user underscore agent. In here I pass the Mozilla 5.0 window. Okay, something like this. Okay, so this means set a user agent. So website don't treat your script like a sadie bot. Okay, so I import this, set a user agent. So this is the user agent, guys. Okay, so set a user agent. So website don't treat your script like sadie bot. Okay, so that's why I use this one. Okay, and after this I have this from langchain dot community, langchain underscore community, and dot document underscore loader. I'm going to import website loader. Okay, with the help of this I'm going to load website URL. Okay, so now, okay, mm, mm, Arre bhai, what happening? Okay, guys, so here, mm, I import this. Okay, set a website that uh, uh, set a user agent so website don't treat your script like sadie bot. Okay, and from LangChain underscore community I'm going to import document underscore loader, import the web loader. Okay, so I'm going to load URL. So loader equals to website loader. Okay, this is the variable name. Okay, I'm going to use web path equals to this one, Wikipedia. I'm going to load this Wikipedia. Okay, large language model, this is the website, guys. I'm going to copy and I can open here. This is our URL. Okay, so we can open here. Okay, so this is the Wikipedia page that I'm going to open here with the help of this URL. Okay, and keyword argument here, bs underscore keyword argument. So it means this avoid the navigation bar, slide panels and footer, etc. 1 minute. Here I mention, I can mention here in comment. Okay, so only extract the main content section of the Wikipedia page. Okay, so this is going to only extract the main, only extract the main content section of the Wikipedia page. Okay, so only extract the main content section of the Wikipedia page with the help of this parts only. I'm using here BS4 soup strainer. Okay, so this is the part of BS4, guys. It is used for scraping, and I use ID equals to this MW hyphen content hyphen text. Okay, so this is giving us only main content section of the Wikipedia page. Okay, and this avoid navigation bar. Okay, navigation bars and navigation bars, side panel, footer, etc. Okay, it avoid the navigation bar, side panel, footer, etc. Okay, you can search there in Wikipedia, inspect content, and you can go and search there. Okay. Okay guys, so I'm going to use this ID. Okay, control F. You need to use control F here, and you can find out this one, this class. Okay, I'm just taking this only. So this is giving us only content. If you know scraping, then it will okay. Okay, so after this I'm going to load the document here. Load the web page and convert it into a LangChain document object. Okay, doc equals to loader dot load. So load the web page and convert it into a LangChain document object. Okay, and now print here. Print how many documents were loaded. Should be one since one URL. Okay. Okay. So print doc 0 page content 500. This help to verify what actually is scraped. Okay, this line. Okay, so print 500 character of the extracted text content. Okay, so here I'm going to run this. So guys, I got this one. Okay, from Wikipedia page. So loaded yeah, here you can see print loaded length of document. So it is giving us loaded one documents because I scrap only one page. Okay, and here print document 0. Okay, so this is the our page. Okay, page content here I have 500 character from starting. Okay, so these are the character type of machine learning model. Okay, unsupervised machine learning, so semi supervised machine learning. Okay, so this is our data from web loader. Okay, now we move here. Okay, text splitting, language nodes. Okay, now we are breaking big document, like we have this document. Okay, now we are breaking big document into small parts. These part are called the chunk. These part are called the chunk means like if you have longer sentence, big paragraph. Okay, then you need to convert this paragraph, I mean big paragraph or longer paragraph, into a small piece of chunk. Okay, so big document equals to small, I need to convert big document into a small chunks for better processing or better understanding. Okay, so we repeat some part between chunks. Okay, so AI does not lose the context. Okay, so here I'm going to explain visual understanding. Okay, so if we have chunk one like this, okay, this is the word 1, word 2 and word C. Okay, so now I'm going to do chunk 1, chunk 2. Okay, so in chunk 2 it is going to take from here. Okay, from here C D E. Okay, in chunk 3 it is going to take from here from E. Okay, इसका मतलब है ये थोड़ा सा लास्ट पार्ट ले ले रहा है. ओके, थोड़ा सा जब दूसरा चंक बनेगा तो पीछे से वो यहाँ से पड़ेगा C D और E. ठीक है, मतलब जो पहला चंक था उसका पीछे से 20% ले ले रहा है. 20% 10% जितना भी है ले ले रहा है ताकि मॉडल इन्फॉर्मेशन फॉरगेट ना कर सके. ठीक है, तो यहाँ से हमने थोड़ा सा ये लिया, मतलब ये चंक के वर्ड 1, वर्ड B, वर्ड C. ओके, नाउ इन सेकेंड चंक इट इज गोइंग टू टेक फ्रॉम हियर. ओके, पहले वाले की यहाँ से लेगा वो. ठीक है, 10% ऑफ फर्स्ट वन ये चंक 2 में यहाँ से लेगा. ओके, सो नाउ इट इज गोइंग टू टेक फ्रॉम चंक 1 20% of chunk 1 in chunk 2. Okay, chunk and then start again. Okay, so like this we can do chunking like this, chunk overlapping. Okay, so we have a list of words. Okay, like I'm doing, I'm keeping size of 50, chunk size of 50. It means in one list we have 50 words. Okay, and chunk overlapping means ये थोड़ा सा जो 20% of chunk 1 we can take in chunk 2. Okay, so here this is the process for chunking and chunk overlapping. जहाँ पर ये overlap हो रहा है, this is called the chunk overlapping. Okay, so why recursive splitter is better? It try the smart splitting, first paragraph, then sentence, and then word. Okay, so split document into small chunks for better AI processing. Okay, so now we will convert the chunk into a vector using embedding. Okay, why we use recursive character text split? I'm going to remove this line here. So you can see here recursive character text splitter. Use multiple rules. Okay, tries paragraph, line, sentence, and word. Keep text more natural. Add overlapping and better understanding. at understanding. Okay, basically it is say let me try to split this nicely like a human would. Okay, तो यहाँ पर ये अच्छे से स्प्लिटिंग करता है, ठीक है, पैराग्राफ वाइज, लाइन, सेंटेंस, वर्ड वाइज. ओके, now we have code for this. For recursive character test splitter. Okay guys, so from LangChain underscore text underscore splitter, I'm going to import character text splitter or recursive character text splitter. Okay, so recursive character text splitter best for most use cases. Try to split on paragraph, then sentence, words and character. Okay, splitter equals to, here I put splitter equals to recursive character text splitter. Okay, I put chunk size equals to 200, maximum character per chunk. Okay, एक chunk में 200 character आएंगे. Okay, so this is called the maximum character per chunk. Chunk size equals to maximum character per chunk. We took 200. Okay, chunk overlapping 30 means overlapping between chunk. For context, हम 30 वर्ड को 30% उसका ओवरलैप कर रहे हैं. ठीक है, सो हियर आई यूज सेपरेटर. Okay, separator. Okay, so here I use separator, so order matter here. Okay, so this one, try to split by paragraph. Okay, try to split first paragraph. Okay, then break the lines. Okay, then break the lines, then by sentence. Okay, and then by words, and finally brute force. Okay, split character if nothing else work. Okay, so dimension here in comment. Okay, so first is try splitting by paragraph. So here I'm going to remove this line. Okay, so you can see here order matters. Okay, first try to splitting by paragraph. Okay, this is for paragraph, and then split by line break. Okay, this one, and then by the sentence, this one. Okay, and then by the sentence, and then by the words, this one is for words, this one, and then finally brute force split character if nothing else work. Okay, so we are going to try split in the order like this. Okay, this is chunk size means maximum per chunk. Okay, maximum size of each chunk in a one in character. Okay, maximum size of each chunk in characters. Okay, and this one chunk overlapping means overlapping between chunk to preserve the context. Okay, so now you can see here I use chunk equals to splitter dot split document. Okay, here I pass the docs, so it split the loaded document into a smaller chunk. Okay, and then print the length of document. Okay, and then print the length of chunks. Okay, how many chunks we are going to use. Okay, this is for empty. Okay, now I'm going to use loop through each chunk and display it. Okay, chunk enumerate chunks. Okay, this is for like 1 2 3. Okay, and print the chunk and this 0 plus 1. Okay, so 1, and here length of chunk page dot content. Okay, so the chunk number and its length. Here with the help of this, it is going to show length of chunk. So chunk number and its length. Okay, and print chunk dot page content means original content. Okay, so you can see here I got this. Okay, original document 1, after splitting I got 808 chunk. Okay, with the help of this original document length 1, and after splitting I got length of chunk, that is 808. Okay, so chunk 1, type of machine learning model. This is the chunk 1 with the help of this 0 plus 1 1. Okay, chunk 1 we have 197 characters. Okay, so type of machine learning model LLM predicted here. Okay, and part of serialization machine learning, supervised learning, unsupervised learning. Okay, but you can see here this is our first chunk. Okay, what you can see here in chunk 2, it is going to take from here. Okay, means it is going to use overlapping. Okay, you can see here it is going to start from here, unsupervised machine learning, semi supervised machine learning. So chunk 2 is start from here. It is going to take some words or character from chunk 1. Okay, means it is going to overlap here. So unsupervised machine learning, here you can see. Okay, so we can also print. Okay, so this is our chunk overlapping, chunk 1 and chunk 2. Okay, and you can see here chunk 3 will start from here. Okay, it is going to cut here. You can maximize this, okay, in output. Okay, so it is going to start from here. Understand? Right. So this is called the chunking, chunk overlapping. Now we have character text splitter. Use only one rule for separator. If new line is missing, bad split and can break sentence randomly. No overlap and context lost. Basically cut here, I don't care what the sentence say. इसमें क्या होता, कहीं से भी कट कर देता, कुछ भी सेंटेंस हो, कुछ भी कहीं से भी, इसको कुछ भी केयर वेयर नहीं है. ओके, सो हम इसको कम ही यूज करते हैं. सो हियर आई एम गोइंग टू इम्पोर्ट लॉगर. ओके, सो हमने यहाँ पर क्या किया, आई इम्पोर्ट लॉगर. ओके, from logging, import logging. It means we are going to like for error. Okay, hide the warning message from the text splitter library. Okay, so it is so like if I get error, then it will give us log. Okay, so hide the warning message from the text splitter library. So that's why I use this logging get logger LangChain text splitter set logging error. ओके, जब आपके पास कोई एरर वेरर होगा या कुछ वार्निंग होगी तो इसको हाइड कर देगा विद द हेल्प ऑफ दिस. आई यूज कैरेक्टर टेक्स्ट स्प्लिटर हियर, स्प्लिट ऑन स्पेसिफिक कैरेक्टर. ओके, एंड हियर आई यूज सेपरेटर दिस वन. Okay, split text where a new line appears. Okay, split text where new line appears with the help of this, and chunk size is 100. Okay, each chunk will have 100 character, and chunk overlapping I use 0, no overlap. Okay, chunk are completely separate. Okay, then I print here, sorry, I create this variable character chunk equals to character, I use this character underscore splitter. I use split document for split the document. Here I pass the document. Okay, previous I load the website loader, so in this I pass the document. Okay, and print the length of character chunks. Okay, and here it with the help of this line, you can see here I'm going to run this. Okay, so character produce 105 chunks. Okay, character text splitter produce 502 chunks with the help of this line. Okay, I got this length of character. Okay, produce, I mean sorry, length of chunks. Okay, now we have this print chunk 0. Okay, so we have chunk 1, chunk 2, so it's chunk 0. Supervised machine learning, unsupervised machine learning, unsupervised machine learning. Oh, here you can see ये कहीं से भी कट कर दे रहा है. Okay, with the help of this. So here you can see with the help of this line it print 50 character of first chunk. Okay, print last 50 character. Minus 50 means it is going to print last 50 character. Okay, last 50 character of first chunk. Okay, so this is our first chunk, and like हमारे पास कोई डॉक्यूमेंट है और उसके वो लास्ट पीछे से 50 कैरेक्टर प्रिंट कर देगा. ओके, and chunk 1 start, this is for chunk 1 start, this is for chunk 1. Okay, so here this is the chunk 1 page content. Okay, so this is giving us from first 50 character. Okay, in chunk 1 this show overlapping between the chunks or print 50 character of the second chunk. Okay, first 50 character of the second chunk. ओके, तो यहाँ पर इसका दूसरा ही रहेगा कुछ, क्योंकि यहाँ पर शुरू से स्टार्ट हो रहा है और वहाँ पर लास्ट से स्टार्ट हो रहे थे. यू कैन सी हियर वी यूज हियर अनसुपरवाइज्ड मशीन लर्निंग एंड इट इज गोइंग टू स्टार्ट हियर. ओके, इट इज ऑल्सो ओवरलैपिंग. Okay, So now we will learn embedding and vector database in 8 module 8, embedding and vector stores. Okay, vector stores means vector database. Okay, this is the most important part of RAG. This is how AI understand meaning, not just word. Okay, so how it work? Embed means we need to convert text into a list of number. Okay, with the help of embedding we need to convert text into a list of number, that is called the vectors. Okay, and store these vector into a vector database. Okay, and if we have user query, if user asks me some question, okay, so embed the user question also. Okay, so I also create the vectors of user question. Okay, and find the most similar store vector and return the top k, or top k means most similar, top two to top k means 1 2 3 whatever. Okay, so it will give you top 2 result, top 3 result, most similar chunks. Okay, so here we convert text into a number with the help of this, and and find the similar meaning means similar number. Okay, and then we search using those numbers. Okay, so we have these steps. Where is this one? Okay, so first convert text into a vector means number. Okay, store these vector inside the vector database. Okay, and then convert user question. Okay, we have user question, convert user question into a vector, and then find the similar vectors. Okay, and then it will return the top result, top k result. Okay, so return the best matching chunk here in top k result. Okay, so here we use Hugging Face. What is the Hugging Face? Hugging Face is also platform. Okay, open source platform. We can use embedding from Hugging Face. Okay, so if you use I'm going to show you Hugging Face. So here you can search Hugging Face. Okay guys, so this is Hugging Face. We are going to use embedding model of Hugging Face. Okay, so Hugging Face embedding models. So guys, these are the embedding models of Hugging Face. Okay, we have multiple different embedding models. Okay, I'm going to use sentence transform, this one. Okay, sentence transform all min lm, this one. Okay, we can copy from here, and then we can use this. Okay, this one, this model, Hugging Face for embedding purpose. Okay, FIS. What is the FIS? FIS is a vector database. Its full form is Facebook Fast Vector Similarity Search. Okay, so simple idea behind of this: convert text into a numeric form. Okay, that is called the vector. Convert text into a number, and these are the vectors. Similar meaning equals to similar vector, and this is the process: convert text into a vector and store inside the vector database. And if we have a question, then we also did the embedding and convert into a vectors. Okay, and find the similar vectors and return the top results. Okay, so AI understand the number, not raw text, so that's why we need to convert into a number. Okay, so we use tools Hugging Face create for embedding. I use Hugging Face model for create the embedding, and files I store this embedding in the form of vector and search the relevant vector. Okay, so in one line we can say we have text and convert into a vectors and store inside the vector database and search. Okay, search and retrieve the answer here. Okay, retrieve the top k. Okay, so here you can see from LangChain underscore Hugging Face, I am going to import Hugging Face embedding. Okay, so here you can see embedding equals to Hugging Face embedding. Okay, here I pass the model name. I use Hugging Face embedding, guys. Okay, convert for embedding. Okay, so I pass the Hugging Face model here. You can see here, this is our Hugging Face model. This one, sentence transform all min, this one. I use this model for embedding purpose. Okay, and I use model underscore keyword arguments. So here device name, I just need to put device name. Okay, so I use CPU, so that's why I need to put CPU here. Encoded argument equals to normalize underscore embedding equals to true. It help in better similarity comparison. मतलब कौन सा ज़्यादा similar है Okay, with the help of this we will find out. Okay, and here Hugging Face embedding convert text into a vector. Okay, and 5 equals to 5 store the vector and find the similarity search. Okay, and this one this one. Okay, normalized vector help in better similarity. Okay, and we are going to run model on CPU. Okay, and this is the model name, embedding model name that I am going to use from Hugging Face. Okay, and now I'm going to print embedding model loaded. Okay, so it is going to print here embedding model loaded here. Okay, nothing than this. Okay, so we are going to run everything. Okay, so run restart, not restart. I need to run everything. Okay, so after this it is going to load here. Okay, but after this here what we are going to understand now, we will convert one sentence into a vector. Okay, this is our one sentence. Now I'm going to convert this vector, this sentence into a vector. Okay, now I'm going to convert one sentence into a vector. Okay, so here it is going loaded 100%. Okay, I'm going to run everything because I close this. Okay, now it is going to run. So here I'm going to convert this sentence into a vector. Okay, so I pass here, I create this vector variable and I pass this embedding. Inside this we have model name, model keyword argument, and encoded keyword arguments. Okay, so here I use this embedding and I use embed query. Okay, embed query is used for, with the help, it is used to convert text into a numbers. Okay, with the help of embedding. Okay, I pass this text here. Okay, then print the text. Okay, so it is giving us text. LangChain is a framework for LLM application, this one. Okay, this text, and then vector, it is giving us dimension of vector. Okay, so here I'm just print a vector from 0 to 5. Okay, so it is giving us 5 vectors. Okay guys, so यहाँ पर ये क्या हो रहा है, we have this text, LangChain का ये वाला vector हो गया. LangChain is sorry, what is the vector? Vector is a list of numbers. Okay, it may be in minus or it may be positive. Okay, so so this is our another word, and we have vectors of this. Okay, we have a, and this is the vector of this. Okay, and framework we have vector of this, for example. Okay, and here we have vectors of this. Okay, and LLM we have vector of this. Okay guys, so these are the vectors of this text. Okay, and its dimension is 384. Okay, note similar text will have similar vectors. Okay, and now we have, you can see here, similar vector have similar meaning. Same meaning equals to similar vector. Vector is just a list of number. AI compared this number. Okay, so after this we have this code. Okay, now we will compare meaning of two sentences. Okay, now we will compare meaning of two sentences. Okay, so we use cosine similarity for this. It tells how similar two vectors are. Okay, so here I pass import numpy as np. Okay, import numpy for math operation. Here मैंने यहाँ पर एक function create किया. I just create one function, cosine similarity. Inside this I pass vector 1 and vector 2. Okay, in vector 1 and vector 2 I pass vector 1 and vector 2 and return here. Okay, np dot v1 and v2. It is the dot product of two vector, guys. Okay, dot product of two vector. In numpy we can calculate dot product of two vector like this. Okay, and this one is used for np dot li nalg dot norm v1. It means length of vector 1. Okay, and it means length of vector 2. Okay, so we can calculate similar cosine similarity with the help of this, and it will return -1 and +1. अब जब आपने cos की वेव देखी होगी तो -1 से +1 में जाती है. ठीक है, so here this function compare two vectors. Okay, and formula we use dot product divided by length of vector 1 into length of vector 2. Okay, result is giving us in between -1 to +1. Okay, now you can see here I'm going to create vector 1 and I'm going to use embedding, this embedding. Okay, this embedding, and I use query, embed query. So I pass in vector 1 this sentence, I I love programming in Python. In vector 2, I pass embedding and embed query. And here I give sentence, Python is my favorite coding language. Okay. And we have another vector. Okay. V3. Here I pass embedding and use embed query. And here sentence, the weather today is sunny and warm. Okay. So here I'm going to find out similarity with the help of cosine similarity. I use this one. Okay, and I pass v1 and v2. Here we are going to calculate similarity in v1 and v2 sentence in between this and this sentence. Okay, हमारे पास दो sentence है, I love programming in Python and Python is my favorite coding language. हम इन दोनों के बीच में similarity find out कर रहे हैं. Okay, and now we have similarity 1 3. Okay, so I'm going to find out cosine similarity in between vector 1 and vector 3. Okay, so हमारा ए वाला sentence है, इसके वेक्टर्स और ई वाला सेंटेंस है, इसके वेक्टर्स के बीच में सिमिलरिटी फाइंड आउट करेंगे. ओके, सो विद द हेल्प ऑफ दिस. सो फ्रेंड सिमिलरिटी पाइथन वर्सेस पाइथन. ओके, सो यू कैन सी हियर v1 एंड v2. तो आप देख रहे हो ना, वी हैव v1 एंड v2. ओके, सो दे आर टॉकिंग अबाउट प्रोग्रामिंग लैंग्वेज पाइथन. ओके, मीन्स बोथ आर सिमिलर. Okay, so Python versus Python. Okay, so it is giving us high similarity. Okay, similarity in between vector 1 and 2. I want result in a float. Okay, float. Okay, 0.3f means float को हमने 3 से multiply किया. Okay, so it is giving us high. Okay, because we want 3 numbers in float, in the form of float. Okay, so here you can see similarity means here it is giving us high similarity because we are talking about here Python and Python in v1 and v2. Okay, and here you can see similarity Python versus weather. Okay, so here first one is related to the Python and third one is related to the weather. Okay, so they don't have any kind of similarity because we have low similarity because of this, because Python versus weather there is no similarity. One is v1 is talking about Python and v3 talking about the weather. Okay, so here it is giving us low similarity in v1 and v3. Okay, this one v1 and v3 similarity in between 1 and 3. Okay, so after this we have this code of lines. Okay, lines of code. So here higher value equals to more similarity. Okay, closure 1 equals to more similar and closure 0 equals to less similar. Okay, here closure 1 equals to more similar and closure 0 equals to less similar. Okay, so now here how we will store our vector in a database. Okay, this database is called the vector store. It helps us to search similar data very fast. Okay, so here I import from LangChain _community vector store import files. Files is the vector database. Okay, so here vector store equals to files. I use files ._format. Dot form underscore document. Okay, I use here chunk. I pass here document equals to chunk. मैंने यहाँ पर document के format में chunk pass की. I pass document as a chunk. Okay, and embedding. Here हमने यहाँ पर similar embedding model use किया. I just use similar embedding model, that this one. Okay, so here I use these are small piece of text. Okay, chunks means small piece of text. Okay, and embedding equals to this convert each chunk into a vector. Okay, with the help of this, and print the vector store created with vector store dot index total. Okay, so total number of vector store with the help of this, and this is the index. Okay, usually number of chunk, so it is going to print. So here you can see vector store created with 27 vectors here. Okay, and here after this we use to here we store text as a vector. Okay, number of vector equals to number of chunk. Okay, so here we store text as a vector. This help us search similar content fast. Okay, so chunk equals to vector, number of chunk equals to number of vector. Okay, so chunk, I need to create chunk into convert chunk into a vector and store in a database. Okay, and here after this all vector are stored for search here. Okay, so files store vectors for fast similarity search. like Google search index. Okay, data is like Google search index, data is pre-stored for fast search. Okay, now we have this. This one chunk, I need to convert this chunk into a vector and store in a vector database, that is 5. Okay, number of vector equals to number of chunk, 5 store a vector for fast similarity search. Okay, here now we have this line, these lines. Okay, so these lines, why we use these lines. Okay, now we will search from one vector database. We will give a question. Okay, and it will return most relevant text chunk. ओके हाँ अब हम एक वेक्टर डेटाबेस में से एक सेंटेंस को सर्च करेंगे. ओके, वी हैव वन क्वेरी. ओके, सो हाउ कैन वी डू दिस? वी हैव वन क्वेरी inside the vector database. I'm going to search this query in the form of vector. Okay, so here we have one query and we have one query. Okay, and we will convert this query into a vector. Okay, and we will match this query inside the vector database with the similarity search and get the top result. Okay, similarity search means meaning searching. Okay, we are searching based on meaning. Okay, so we have one query, who created LangChain, and result equals to vector store. Vector store means vector database. Okay, similarity search, with the help of this we are going to search similar word. Here I am going to pass query similar word based on meaning. Okay, with the help of this I am going to pass query, and k2 equals to means top 2 result. Okay, convert query into vectors here. Okay, and compare with store vector. Okay, and return top 2 most similar result here. Okay, and print the query and print the length of result here. Okay, and here I use loop. Okay, so loop throw, here I use loop throw each result. Okay, मैंने यहाँ पर जो भी डॉक्यूमेंट था, जो भी रिजल्ट था उसके अंदर मैंने यहाँ पर लूप लगाया, और I means index. Okay, so it is going to use result. Okay, so here loop throw each result one by one from 1 to जितनी भी रिजल्ट होंगे वहाँ पर, यहाँ पर रिटर्न रिजल्ट करेगा, result 1 result 2 like this. Okay, with the help of this line. And document page content means it is giving us real content like this. Okay, so what is the question? Who created LangChain? This is a question, who created a LangChain. Okay, and found 2 relevant chunks. Okay, we find out 2 relevant chunk. This one length of chunk is 2, हमने यहाँ पर 2 दिया था ना, k2, and chunk length of this, these are 2 result. Okay, top one LangChain overview, document by LangChain to maintain the भाई ये क्या दे रहा है? I'm going to rerun again. Okay, so this is giving us result 1 and result 2. Okay guys, but I mentioned previously this who created LangChain, but it is not giving proper answer. Okay, it is not giving us proper answer. It is now giving like this. Okay, so I'm going to change, because we don't have this in our document. Okay, I'm going to change question, what is LLM? Okay, I'm going to search here, what is an LLM? Relevant chunk is LLM is a type of foundation model trained on language. LLM can be trained in different way. Okay, can make an LLM output less relevant. Okay, so these are the 2 result I got from here. Okay, so now we are going to do score. Okay, so less score means more similarity, less score means more similarity, and more score means less similarity. Okay, so here I create one variable, result with score, result underscore with underscore score. I use vector. Okay, dot similarity underscore search underscore with underscore score, and query I pass here. Okay, and k equals to 3. Okay, k equals to 3 means top 3. So search top 3 similar chunk and also return the score for each result. Okay, so with the help of score we will know the similarity. Okay, कि क्वेश्चन कितना क्वेरी कितनी मैच कर रही है उसके आंसर से. Okay, so I use loop. Okay, loop throw document and score in result with score here. Okay, and here I use doc equals to doc means text of chunk. Okay, score means similarity scores. Okay, now I'm going to print score in dot f4 means 4 last in float. After decimal we need 4 digit. Okay, like this. Okay, so here lower score equals to more similar and high score means less similar. Okay, so lower equals to more similar in L2 distance. Okay, print f content and doc dot page content, first 100 character of the content. Okay guys, so score means हमारे पास कोई क्वेरी है, वो क्वेरी वेक्टर डीबी के अंदर जाएगी और उसमें मैच करेगा विद द हेल्प ऑफ सिमिलरिटी सर्च, क्यों कौन सा स्कोर, मतलब क्वेरी जो है उसका आंसर किस डॉक्यूमेंट और किस लाइन से ज़्यादा मिल रहा है, तो उसका स्कोर फाइंड आउट करेगा. ओके, सो हियर मैं इसको रन करूँगी. आई एम गोइंग टू रन दिस सो यू कैन सी हियर. Okay, LLM is type of fundamental foundation model. Okay, so this is our first question. Suppose we have this question, what is an LLM? Okay, then we got result 1, this one, and result 2, this one. Okay, so you can see here result 1, LLM is a type of foundation model. Okay, you can see here LLM is a type of foundation model, this one. Okay, so you can see here this has less score, lower score means more similar. ओके मतलब ये जो क्वेश्चन है, इस क्वेश्चन है दिस वन, व्हाट इज LLM. ओके, एंड दिस इज द रिजल्ट. इट हैज लेस स्कोर, आई मीन लेस स्कोर, लोअर स्कोर मीन्स मोर सिमिलर. सो ये जो क्वेश्चन है इससे ज़्यादा मैच खा रहा है, सो इसका करेक्ट आंसर यही है. ओके, सो नाउ वी हैव दिस वन, दिस सेकेंड रिजल्ट. ओके, दिस वन can make LLM output less reliable, this one. Okay, so this is not giving us less score. You can see here like score is more than this. Okay, so this is not scoring properly here. Okay, so this is not similar, I mean more score, less similarity. Okay, so ये match नहीं कर रहा अपने output. So you can see here it is not going to match from this output. Okay, and you can see here this one 0.76, this is also like more score. Okay, this is also not going to match. Okay, the LLM while memory can integrate it as a tool or provided additional input. Okay, so this is also not going to match. Okay guys, so this ये आंसर हमें कहाँ से मिल रहा है, डॉक्यूमेंट से चेक कर रहा है. We have document. Okay, I already use Wikipedia. Okay, Wikipedia link, so it is coming from here, Wikipedia, in this website. Okay, तो हमारा जो डॉक्यूमेंट है, like if we have I mean we have document. Okay, then we have query. It is going to find out similar word with the help of scoring. Okay, if less score more similar. Okay, or more score less similar, that's it. So after this, now after scoring, now I'm going to save and load vector store here. Okay, so here I create vector store and save vector store. Okay, dot save underscore local. Okay, file index, I'm going to save this in our local machine and print vector store loaded by using this. Okay, and loaded vector store equals to files. Files is a vector database guys. I'm going to show you what is files. So here files vector db. Okay, so files, what is files? Facebook AI similarity search. Its full form is Facebook AI similarity search. It's a library designed for efficiently similarity search and clustering of dense vector. Okay, so this is kind of vector database. We are going to search similar word with the help of similarity search inside this vector database. Okay, so here I use this files. Okay, file dot load local, load underscore local. Okay, I already saved this in our local machine. Now I'm going to load this from our local machine, or I'm going to use this embedding, same embedding guys. Okay, same embedding that previously I used, this embedding model. Where is it? Here inside this we have this one, sentence transform. Okay, so I use sentence transform from Hugging Face. Okay, this one, sentence transform. I use this one, guys. Okay, sentence transform, almin lm, whatever. Okay, so I use this one, or you can see here I already have embedding code here. Where is it? Let me show you where I did embedding, guys. I can search here. Arre, 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 arre. Okay, I can search embedding. Okay, I'm going to use this embedding. Embedding equals to Hugging Face embedding. Okay, I'm going to use this embedding here. Okay, similar embedding here. Okay, allow underscore dangerous deserialization equals to true. Okay, it means it allow to load this folder from the local and use this embedding. Okay, print the vector store loaded here. It is going to print and print the loaded vs, this one, index and total number of chunks, total number of vectors. Okay, so we got this total number of vectors, and vector store loaded is giving us this. Okay, you can see here I got this folder name here, files underscore index. Okay, this is the folder name, files underscore. I save here this folder. Okay, and print vector loaded, vector store saved, and I use this here. Okay, files index, and I also use same embedding. Okay, now after this we are here. Okay, now turn vector store into retriever. Okay, the standard interface, we have retriever. Retrievers means we want something from vector database. Okay, now we are going to retrieve. So here we have this retriever, and this is the vector database. I'm going to use here in vector database as a retriever. Okay, so I'm going to retrieve something from vector database with the help of this line. Okay, I use here search type equals to similarity. Okay, similarity is used for searching meaning based content. Okay, it is giving us meaning based content. Randomly ऐसे कहीं से भी काट पीट के नहीं दे देगी, ये meaning को understand करेगी, then it will give us. Okay, search underscore keyword arguments here, k equals to 3 means I want top 3 result. Okay, retrieve document for a query, so I mention here retrieve underscore document equals to retriever. I use this retriever, this one here. I have similarity search and top 3 result I want, and I mention here invoke. Invoke means ask something. Okay, retrieve document equals to retriever, and I'm asking what are the main component of LangChain. Okay, I can ask anything, main component of the LangChain. Okay, so convert question into a vectors. First it is going to convert question into a vector and search similar chunk inside the vector database. Okay, and return the relevant document. Okay, top 3 document, and print length of relevant underscore document. Okay, so we have 3 documents. Okay, for here I use loop for document in relevant document. Okay, print the first 200 character of each chunk here. Okay, doc dot page content 200. Okay, so we got this answer. You can use this another thing, like if we have a Wikipedia, this one. So here I can say, you can say what is history history of what? LLM. I'm just giving and trying. Okay, so it is giving us history of LLM in 3 point. Okay, 3 document. LLM is a type of foundation model trained in a one language. LLM can train on a different way. Okay, it is giving like answer this. Okay, guys, in 3 points. Or you can ask me. You can ask me here. You can ask here. Okay, what is large language model? Okay, so it is giving answer like this. Or I can give here type of LLM. Okay, so LLM is a type of foundation model trained on language. LLM can train in different way. Okay, so guys, it is giving answer in 200 character. If you want more, then you can write like this. Okay, 500. It is giving same. Or if you want 100, then it is giving us 100. Okay, 100 character. Okay, guys, so I hope you got it. So, okay, guys, now we are going to understand module 9, RAG, retrieval augmentation generation. Okay, so RAG means retrieval augmentation generation. It helps AI answer using your own data. Okay, so generally AI answer from its training data, but with RAG, AI first search your data, then give answer using the data. Okay, so these are, this is the diagram. Okay, we are going to follow this diagram here. Okay, first user. Okay, when user ask the question here, when user ask the question, first system receive it. Okay, and then this question goes to the retriever here. Okay, which work like a smart search engine. It does not guess anything, it only search in store database. Okay, in store data. Okay, it is going to search in a store data, or we use here files, that is our vector db. Okay, so we have user question and user ask the question here, and this question goes here into the retrieval. Okay, this is the smart retrieval. Okay, it which work like a smart search engine. It does not guessing anything, it only search data here inside the vector database. Okay, and then the retriever find the most relevant. Here retriever find the most relevant chunk. Okay, retriever find the most relevant text species here, text species or text chunks. Okay, text species or relevant text chunk. Okay, okay, to the question. So retriever find the most relevant chunk related to the question. Okay, and then LLM read the context and understand the question together. Okay, LLM read here context and understand the question together. Okay, and finally it generate a clear and correct answer based on the information. Okay, first we have user question, then user question goes here in retrieval is like a smart search engine. Okay, it is going to search here in a vector database and find the relevant text of chunk, and then LLM understand this context and answer and question. Okay, and then generate the final answer. That's it, guys. This is just RAG pipeline. Okay, so here retrieve augmentation generation. Okay, it means we first find the relevant document and then we send them to the LLM and generate the answer. Okay, so I'm going to install pip install LangChain community, LangChain community and LangChain grok 5 CPU. This one for vector database, that is files. I'm going to use files. Okay, sentence transform. So here, guys, you can see here I have this Hugging Face like a this is a open source platform. Okay, so we can use this model for embedding. Okay, this model for embedding. So here inside this I'm going to use this model. Okay, so here I'm going to import from .env. I'm going to import load .env. Okay, so what does it mean? 1 minute. So here from .env import .env, load the variable from the env file. Okay, I have this env file, I'm going to load this. Okay, API key with the help of this. Import OS means allow access to the system environment variable. Okay, and with the help of this load underscore .env actually load the env file into the environment, into the system. Okay, and this is the API key variable. Inside this we have, okay, inside this we have this one grok API key. Okay, and now OS, I use os.getEnv, I pass the grok API key and print the API key loaded. Okay, so after installing this you need to click here like this. Okay, and you need to click here. Okay, hit shift plus enter button. Okay, so it say API is loaded. Now I'm doing embedding here. Okay, embedding. So from Hugging Face I'm going to import okay, so here you can see from LangChain underscore Hugging Face I'm going to import Hugging Face embedding. Okay guys, so I'm going to use this embedding from Hugging Face. Where is it? This one sentence transform. This is the embedding model guys. Okay, it is going to convert our text into a numeric format, okay, or vector form. Okay, so embedding equals to I use Hugging Face embedding and model name sentence transform almin. Okay, so this is the model name and print the embedding is ready. Okay guys, now I'm going to load our data. Okay, so here I'm going to copy from here. I'm going to load our own data. Okay, so this is the text. LangChain is a framework for building LLM application. It was created by Harrison Chess. It helps in building AI app quickly. Okay. So here I'm going to import text loader from LangChain underscore community document underscore loader. So with the help of this, I'm going to use text loader. It will help to load the text document. Okay, so here you can see here. Okay, so this one is sample text data we want to use in this rack. Okay, and this is the tool that convert file into the LangChain document format. Okay, and this one with open sample.txt as f. Okay, so here I'm going to create a file and save text inside it. Okay, so हमने एक sample.txt नाम की एक फाइल बनाई, उसको एज अ राइट हमने एक sample.txt फाइल बनाई उसको, और उसमें हमने ये टेक्स्ट डाल दिया, दिस वन. Okay, so I have created one file and save the text inside this. Okay, f.write text. Okay, now I'm going to load this file. Okay, loader equals to text load. With the help of this I'm going to load this file. Okay, so load file into a LangChain loader. Okay, and then doc equals to loader dot load, convert file into document object. Okay, document equals to loader dot load, so it is going to convert file into document object. Okay, and print, it is going to print actual text inside the document. Okay, here actual text inside the document, zero document. Okay, first document, we have only one document. Okay, so LangChain is a framework for building a LLM application. It is giving us this, and it was created by Harrison Chess and it helped in building AI app. Okay, now we are going to split a text. Okay, so I'm going to use code. Okay, text splitter. So you can see here I use recursive text splitter. It is going to split the text. So I from LangChain underscore text underscore splitter I'm going to use text recursive character text splitter. Import the tool to break big text into a small chunks. Okay, So this will break big text into small chunks. Okay, and here I use this line, splitter equals to character text splitter, this one. I pass here chunk size is 100. Okay, each chunk will have maximum 100 character. ठीक है, 100 कैरेक्टर से हमें, जैसे कि हमारे पास बहुत लंबा पैराग्राफ, इफ़ वी हैव लॉन्ग पैराग्राफ, ओके, और उसमें हम 100 करके ले लेते हैं। 100 एक बारी में ले लिया, दूसरी बारी में 100 ले लिया, तीसरी बारी में 100, ऐसे मल्टीपल टाइम आप 100 करके ले लो। सो ईच चंक विल हैव मैक्सिमम 100 कैरेक्टर एंड ओवरलैपिंग इक्वल्स टू 20। ओके, सो ओवरलैपिंग मीन्स लाइक हमारे पास कोई चंक है, मान लो ये हमारा चंक है, इसमें 4 वर्ड है, ठीक है, लेकिन नेक्स्ट टाइम में हम 2 पीछे से लेंगे, 20% ले लेंगे और इसको ऐसे पढ़ लेंगे, ठीक है, मतलब 20% ऑफ जो प्रीवियस वाला रहेगा उसको बोलेंगे ओवरलैप, ठीक है। तो नाउ वी हैव वन वेरिएबल चंक इक्वल्स टू स्प्लिटर डॉट स्प्लिट अंडरस्कोर डॉक्यूमेंट। ओके, हियर आई पास this document, okay, this document. So you can see here I have this sample.txt. okay, I already load this one. Inside this we have this content. तो यहाँ पर मैंने जो भी लिखा था ना वो सब इस फाइल में आ गया sample.txt में, ठीक है। तो sample.txt में तो उसी के डॉक्यूमेंट को मैंने यहाँ पर लोड कर लिया, सॉरी यहाँ पर लोड किया था, एंड देन उसने उसका डेटा प्रिंट किया था। ओके, नाउ chunk equals to splitter dot split underscore document and docs. Okay, so it split document into small multiple pieces. Okay, split document into multiple small pieces. Okay, then it is going to print length of chunk. Okay, print how many chunk we were created. Okay, it is saying 2. हमने 100 के लिए थे, एक चंक में 100 कैरेक्टर, तो मतलब 200 होंगे, तो इसने 2 चंक क्रिएट करे। ओके, नाउ वी हैव वेक्टर स्टोर। तो हमने एक वेक्टर स्टोर बनाया था। आई एम गोइंग टू यूज फाइल्स इज अ वेक्टर डीबी। ओके, सो हियर यू कैन सी files. Okay, so I'm going to import files from LangChain underscore community vector store. Okay, so this is the vector db. Okay, vector store equals to files dot from document. I pass here chunk. Okay, because we are going to store this chunk in a vector database in the form of vector. Okay, so I also pass here embedding. Okay, with the help of this embedding, this chunk convert into a vectors. Okay, and then print the vector db is created. हमने वेक्टर डीबी के अंदर चंक पास की और एम्बेडिंग पास की, ठीक है। विद द हेल्प ऑफ दिस इट विल कन्वर्ट इनटू अ वेक्टर्स। ओके, सो वी कन्वर्ट टेक्स्ट चंक इनटू अ वेक्टर numbers and store them into a file so we can search similar content quickly. Okay, so file equals to memory system for AI that store embedding and allow fast searching. Okay, now we use retriever. Okay, so retriever equals to vector store and dot as retriever. Okay, so convert 5 vector store into a retriever. Okay, convert 5 vector store into a retriever. Okay, so retriever equals to vector store dot as a retriever. Okay, and document equals to retriever invoke. Okay, so यहाँ पर हमें कुछ आंसर रिट्रीव हुए फ्रॉम वेक्टर डेटाबेस। Okay, so I'm creating one variable and with the help of retriever जो भी हमें चीज़ें यहाँ पर रिट्रीव हुई, okay, with the help of retriever's output I'm going to ask who created LangChain. Okay, so here take your question, this one here, okay, and convert into a embedding. Again we are going to convert this into a embedding internally. Okay guys, and search similar vector in a files. in this. Okay, it is going to search similar vector in a file internally and return the most relevant document here. Okay, so I'm going to use loop for D in a document, and it is going to return original content. Okay, so D in document and print D dot page content, this one. So load through all retrieval document here. Okay, and print the actual text content of each matching document with the help of this. So who created LangChain? So LangChain is a framework for building LLM application. It was created by the Harrison Chess. It helped in building AI apps quickly. Okay, and retriever equals to search engine for your private data. Okay, so now we use LLM here. Okay, so I'm going to import chatgrok here because I'm going to use grok. So from LangChain underscore grok, I'm going to import chatgrok, and here I create one variable LLM equals to chatgrok, and I pass model name. This is our model name, and print LLM ready. Okay guys, so here it is say LLM is ready. Okay, now in step 7, okay, rack chain, I'm just creating chain. Okay, so you can see here rack chain. I'm going to import chat prompt template for chat from LangChain core.prompt. Okay, I'm going to prompt chat prompt template. I'm going to use chat prompt template. This is just a simple chat prompt template. Okay, and LangChain underscore core, I'm going to use output parser and import output parser, that it will giving us output in a string format. Okay, in LangChain underscore core runnable, import the runnable pass through. Okay, what is runnable pass through? We can search here runnable pass through in LangChain. Okay, array, what happening? Okay, you can see here runnable pass through in LangChain, this line runnable pass through in LangChain. Okay, it return it I mean return the input. It return the input received without any modification. Okay, so it will return the input without any modification. Okay, so after this, okay, so I create one function format document. Here I pass the document, this document. Okay, this document, I already have content in document. Okay, I pass the content here inside the document. Okay, and here I'm going to join every page of content from the document. Okay, and return the page content here, return the page content here. Okay, and I got this content from the documents. Okay, and then join here. This is simple loop guys. Okay, and now I'm going to create prompt equals to chat prompt template dot from message. So here I pass the system message answer using only context, and human message. Okay, and human message I pass here context and question. Okay, so this is the human message and this is the system message. Okay, so this is simply prompt, and I'm going to create here chain means we are going to connect something in a sequence. Okay, so here I pass the in dictionary, I pass the context, and here I use retriever this retriever, where is it, retriever. Okay, relevant result I got from the retriever. Okay, then I'm going to connect it format document. Okay, here. Okay, this is for like giving for format document. Okay, and here question I pass here runnable pass through without change it as it is. Okay, जैसे हमारे पास था वैसे ही send कर देगा without change. Okay, and here it is going to connect with prompt and then LLM with pipe operator. ये दिख रहा डंडा guys, डंडा है pipe operator. Okay, लंबा सा, and then again I'm going to connect this LLM to the output parser here. Okay guys, so this is the chain only. So print the rag ready. Okay, so rag is ready now. Now I'm going to test. So question is who created LangChain? Okay, so print the reg chain. I'm going to use this reg chain because हमने यहाँ पर सब पास कर दिया, LLM भी पास कर दिया, prompt भी and output भी. So I'm going to use this reg underscore chain. I'm going to invoke means asking something, and this is the question. Okay, so I'm going to run this. So it is giving answer. Harrison Chess created LangChain. Okay guys, so this is simple reg pipeline. First we just use this flow: user question, retrieve the document from the vector database, and we got the relevant result here. Okay, then LLM generate the final answer. That's it guys. Okay, so here we use API key here, and then we did embedding. Okay, and then with the help of this embedding we store vectors inside. I mean, we get our vectors and store inside the vector database. Okay, here we load the data and split the text is small piece and store inside this vector db. Okay, then retrieve the relevant chunks or top relevant chunks from the retriever. Okay, then pass then we use LLM, and then we use LLM here. I write here code for LLM, and then I'm going to create chain. Inside this chain I pass everything, prompt, LLM, and output. Okay, output parts and here this is giving us answer. So this is basic reg pipeline guys. Okay, okay guys, so now we are going to move here in file number 3, LangChain underscore LangGraph agent for beginner. Okay, LangChain LangGraph agent underscore beginner .ipynb file. Okay, so this is our file, LangChain LangGraph agent and tool for beginner. Okay, so this notebook is simple for beginner project. Okay, that's so how to build an AI agent using LangChain. Okay, this one LangChain, Grok LLM, custom tool, and React region plus Act framework. Okay, so let me help you to understand this. Okay, so what this project is about? This project demonstrate how to turn a normal language model into an agent. Okay, that can think and use tool. Instead of just chatting, the model can perform the calculation and process text and decide which tool to use and give the structure answer. Okay, key idea about this: no, we have normally an LLM. Okay, only generate the text. LLM only generate the text normally. Okay, with the LangGraph agent, the LLM can think. Okay, LLM can think and choose the tool. Okay, LLM can think and choose the tool and act and respond. LLM can think, LLM can choose the tool and act and response here. Okay, so what is the tool? Tool just a normal Python function that the AI is allowed to use. For example, add two numbers, count the words, search something, and call API. These are the tools, right? The tools means normal Python function, nothing else. Okay, now you can see here tool use in this notebook. Okay, so I'm going to use here additional multiplication tool and word count and text transformation. Okay, these tools help the agent perform real operation instead of guessing. Okay, what is an agent? Now, what is the agent? Agent is a system that connect everything together. It has LLM brain or tools. Okay, and decision logics when to use tool. Okay, and simple idea: agent equals to AI that can think. Okay, agent equals to AI that can think and choose action plus use the tools. Okay, so agent means AI. Agent is AI that can think and choose the action and use the tools, or it can decide what kind of tools I need to use. Okay, so how agent work in real flow? So you can see here user ask 10 plus 5. Okay, agent does this. Okay, first it read the question. Agent read the question and think, this is this from math? Yeah, this is from math. Okay, choose the tool. It is going to choose add underscore number. Okay, call the tool, add number 10 5. Okay, and get the result 15 or return the answer. Okay, so here agent think can AI, agent that can think. Okay, okay, and choose the action and use the tool. Okay, now I'm going to use here React agent. Okay, so I'm going to show you what is React agent. Okay, so React stand for React, RE means reasoning, means thinking about the problem. Act means acting, using the tool to solve it. Okay, reasoning plus acting. React means reasoning plus acting. Okay, so we are going to use this. And so the agent read the question, think what is needed, use a tool if required, and return the final answer. Okay, so final goal of this notebook, by the end you will build an AI system that understand user query and use tool automatically and solve the problem step by step. Behave like a mini AI assistant. Okay, and you can see here summary. So this is the beginner friend setup to learn how modern AI agent work using LangChain and LangGraph. Okay, tool equals to a function that does work, or agent, the system that decide which tool to use and when. Okay, I'm going to install this pip install -q LangChain. Okay, LangChain underscore core, LangChain hyphen core, and LangChain community, and LangChain grok. Okay, I'm going to use this, and LangGraph, and duck search. Okay, and python.ini. Duck search is used for internet searching. Okay, so I'm going to click here. It is going to install everything. These are the inbuilt libraries, okay, from LangChain. Now here I'm going to import. Okay, I'm going to import .env, load .env from .env file. Okay, I have this env file. Inside this we have API key, so I'm going to load this. Okay, I'm going to load chatgrok. Okay, from langchain underscore grok I'm going to import chatgrok, that we can access the grok models. Okay, so here with the help of this it is going to load the API key in the system. Okay, llm equals to chatgrok. This is the instance of llm. Here I'm going to load the llm with the model with the help of chatgrok. Okay, model name is this llama 3.1 8 billion instant. Okay, and temperature equals to 0.7. Okay, temperature will give you randomness of your output. Okay, and here I'm going to print llm loaded. Okay, okay, so after this, okay, here I connect model. Okay, and I already passed the temperature here and print the llm load. Okay, so now I'm going to use tools. Okay, so why we are creating tools here? Good at talking. Tools good at talking, bad at doing exact operation. Okay, so example, math make mistake, word count means unreliable, and string operation inconsistent. So we can create tool, give the agent real function it can call the instead of guessing. Okay, so हमारे पास I already have tools. Okay, सो वी गिव द एजेंट रियल फंक्शन इट कैन इंस्टेड ऑफ गैसिंग. तो यहाँ पर हम क्या कर रहे हैं, एजेंट को रियल फंक्शन दे रहे हैं. ठीक है, ठीक है, ताकि वो गैस ना करे और ये टूल्स यूज करें. सो यू कैन सी हियर वन बाय वन. Okay, so from langchain underscore core dot tool I'm going to import tool. Okay, so here in decorator I mention here tool. Okay, so I create one function is normal function, it's called the tool. Okay, so def add number. Here I pass a in float and b in float. I want output in float. Okay, add two number together. Okay, return a plus b. Okay, so this is adding number. Okay, now we have another tool, that is multiplication. This one. Okay, this one is used for multiply the number. I use a and b as a parameter. Both are in float and output in float. Multiply two number. Here I return a and b. Okay, now we have another get word count. Okay, this is used for count the word. Okay, count the number of the word in a text. I pass here text in a string, output in an integer because I want the count. Okay, return the length of text dot split. Okay, and now we have another tools, uppercase. Okay, it is going to convert text into a uppercase. Okay, in capital letter. Okay, so return the text dot upper. Okay, now we are going to add these all. Okay, add a number. Here I mention add a number, multiply number, this one, multiply number, get underscore word count, this one, and two upper use cases, this one. Okay, now I'm going to print name for t in tool. I'm going to print name of these tools. Okay, so add numbers, multiply number, get word, and two uppercase, get underscore word underscore count, and two underscore uppercase. Okay, so these are our tools. Okay, so we are creating this tools because we are giving this to the agent. Okay, so this give the agent real function. Okay, so we are giving here these real function to the agent. Okay, it can call instead of guessing. Agent now use these tools, okay, instead of guessing. So after this, okay guys, now I've finished with tool. These are the tools. Now I'm going to create react agent. Okay, react means reason plus acting. Okay, the model think about the question and decide if needed a tool, use the tool and return the final answer. Okay, it decide if need a tool or what kind of tool I need. Okay, use the tool and return the final answer. Okay, so I import from LangChain dot prebuild, import create underscore react underscore agent. Okay, so agent equals to, I mentioned there, react underscore, sorry, create underscore react underscore agent. I pass here LLM. This LLM, where is it? I already mentioned LLM has brain. Okay, so that's why I need to put here LLM. Without LLM, how can it generate the answer? Okay, so I put here LLM and I put here tools, these tools. Okay, as a parameter, I'm going to ask print agent create. Okay, now it is print like agent create. Okay, okay, so create react agent has been moved to the LangChain agent, please. Okay, so this is giving us warning. Okay, forget this. Okay, now you can see here, I just print here agent created. Okay, and this is the agent created, and this is the agent created. Okay, now you can see here, I'm going to use this. Okay, this react agent here. So response equals to, response is variable. Okay, response equals to agent. I'm going to use this agent dot invoke. Okay, invoke means asking something. Okay, I'm going to ask something in a message, and here I'm giving user message. What is 10 plus 5 and 3 into 7? Okay, and it is giving here in response. I use this response message, I want last content. Okay, so it is giving us what? So the result of the function are 15, 10 plus 10, 15. Okay, the result of the function, that is 15, 10 plus 5, 15, and 2 3 into 7 is 21. Okay, so here this is basically use math tool. Okay, what kind of tool it is going to use? Math tool. Okay, okay, it is going to use math tool. We have this one, add the number. Okay, first it is going to use these tools and add the two numbers. Okay, and then we have multiply the two numbers, then it is going to use multiply the two number, these tools. Okay, it is going to use two tools, one for add the number and second for multiply the number automatically. So the model think about the question. Okay, so it is going to think about this question and decide if need a tool. Yes, need, yes, we need here tool. Okay, and then it is going to use the tool. It is use first add number tool and then multiply the two numbers tool. Okay, and then return the final answer. Okay, here it is going to think LLM. Here you can see basically LLM plus tool plus agent. Okay, LLM plus tool plus agent equals to think plus act plus answer. Okay, so here we got our answer. I hope you got it in simple English. So guys, this is our agent and tool. You can create another question and ask here. Okay. You can also remove this one. Maybe it is giving error. Yeah, error. We want last. Okay, now it is giving what is 10 plus 5 and 3 plus 7. Okay, it is giving like this. If you put 0 here, okay, if you put minus 2 here, it is giving us only 21, this one. Okay, if you print here minus 3, is it giving something or not? It is giving error. Okay, so here I need to put minus 1. It is giving last one. Okay, and you can mention here you can change the question and you can use this. Okay, now it is finished guys. I'm not going to use anything. I'm going to put 0 here. Okay, what so it is giving this question. Okay, and here I use -1 and it is giving us this total answer. Okay, so this is also one project with the help of React agent. Okay, so after everything, okay, I'm going to create one project here in the project folder. Okay, inside this I'm going to create files. Okay, so here I have one file, that is f.py. Okay, and I mentioned this one. Okay guys, so I use f.py for Streamlit UI only. Okay, and I use this one AI plus reg logic, this one. This file also I'm going to create in this folder. Okay, and again we have this file requirement.txt. Okay, so yeah, I already have requirement.txt. I need to change. Okay, I move here this requirement.txt here. Okay, so I will delete this file. Okay, so I'm going to here proper project f.py reg underscore backend py and requirement.txt. Okay, here I write, I mean I mention here in this file I'm going to create what AI plus reg logic, okay, for clean backend. And in app.py, I'm going to use Streamlit UI. What is the Streamlit, guys? Streamlit I use for building the UI, okay, for AI ML project. That's it. Okay, you can do Google if you want to know more about it. Okay, now you can see here in requirement.txt we have Streamlit for UI. Okay, LangChain. I'm going to install these. Okay, libraries LangChain under LangChain hyphen community, LangChain underscore hyphen grok. Okay, LangChain hyphen hugging face. Okay, file CPU and sentence transform. This is the embedding. Okay, and PyPDF. Okay, if I'm going to use PDF. Okay, so I'm going to open my terminal. Okay, and here first I need to create virtual environment. Okay, python hyphen m vnv. Okay, I'm going to create this virtual environment. If you know Python, then you will I mean you already know this virtual and what is the virtual environment. Okay, we can install everything inside this virtual environment. Okay, so you can see here I got this one folder here. Okay, virtual environment, this one. Now I'm going to clear this. Okay, and I'm going to open, sorry, I'm going to active this virtual environment. So how can I active? So I have one command, this one. I'm going to use this command to active this virtual environment. Okay, so you can see here now I activated our virtual environment. Okay, now after this I'm going to enter in this folder. Okay, project cd folder name project. Okay, now I am in this project. We can check here what kind of file we have inside this. I have app.py, reg backend and requirement.txt. Okay, now I'm going to install libraries what I have inside the requirement.txt. So I'm going to clean this. Okay, so with the help of this command pip install -r requirement.txt, I'm going to use this line, then it will install everything from requirement.txt. I'm going to enter what I'm going to click in enter button. Okay, it is going to install everything. It took some time and install everything. So hello guys, now I'm going to build one chatbot. Okay, so this project is a simple AI chatbot that can read your PDF or text file and answer question based on that document only. Okay, so you can see here I'm going to build this AI chatbot, and first we take the document in PDF form or in a text format. Okay, then we break it into a small parts with the help of chunks. Okay, we are going to split our document here in different multiple parts. Okay, or here after this then we convert text into a numbers here. Okay, and then we store here. Okay, we store those number here in vector database. Okay, we use files. Okay, so we store those number in a vector database, and then user ask the question here. Okay, user ask the question here Then with the help of similarity search, okay, with the help of similarity search, we find the similar chunk inside this vector database. Okay, and here AI give the final answer. Okay, so I use grok model, so here grok give the final answer. Okay, here generate the final answer. Okay guys, so this is the process. First we take the document, okay, then split into a small chunk, and then we convert this chunks into a number, okay, and store inside the vector database. And user ask the question, we find the similar chunk, okay, then LLM generate the final answer here. That's it. Okay, we have document, then split document and convert into a vectors or numbers, and then we store, and user ask the question, and with the help of searching similarity search, AI generate the answer here, final answer. Okay, so this is the process simply. Okay, I hope you got it. Okay, now you can see here I'm going to write this file, this one, reg underscore backend.py. This is our first file I'm going to write here. Okay, so this file is created to handle all AI logic of the project, like reading the document, understanding the text, storing the knowledge, and answering the question using AI. Okay, in short, I'm going to say this file convert your document into a smart searchable AI knowledge system. Okay, so here I'm going to write some code. I'm going to import. Okay, so here you can see I import here temp file. Okay, temp file means create a temporary file. Okay, temporary file to store the upload document. Okay, so import temp file means create a temporary file to store the uploaded document. Okay, I'm going to import os used to handle system file and environment variable. Okay, now I'm going to import, okay, load underscore dot env from dot env. Okay, so this means load a dot env file. Okay, with the help of this we are going to load our env file. Okay, now from LangChain underscore community dot document underscore loader, I'm going to load PDF loader and text loader. Okay, so this will use to read your PDF file, sorry, this will use for upload your PDF file and text file. Okay, so here with the help of this we can read PDF or text file. Okay, read PDF or text file and extract text from them with the help of this. Okay, and now we are going to use LangChain underscore splitter. LangChain underscore text underscore splitter. I am going to import recursive character text splitter. Okay, it will help us to split big text into small chunks. Okay, so AI can process easily. Okay, now you can see here LangChain underscore community dot vector store. I'm going to import files. Okay, file store text embedding and allow fast similarity search. Okay, so here you can see from LangChain underscore hugging face import hugging face embedding. Okay, so from LangChain underscore hugging face I'm going to import hugging face embedding. So convert text into a numeric vector with the help of this embedding. Okay, here now you can see here from LangChain underscore grok I'm going to import chat grok. Okay, chat grok. Okay, so here now we can read our env file. So here I'm going to load our env file. Okay, so inside this env file I have my grok API key. Okay, you can search here and find your grok API key. Okay, mention like this grok API key. Okay, you need to log in and find out your API key. Okay, so here you need to log in and click on API keys. Guys, I don't want to log in here. Okay, so I already have API keys here. Okay, in my env file. Okay, and with the variable name is grok underscore API underscore key. Okay, API key equals to os dot get API keys. Okay, so with the help of this we load the environment variable from .env file, and here with the help of this we get grok API key from .env file. Okay, okay, now if this is for safety purpose, okay, safety check, if not API key, then it will raise the error grok API key is not found in env file. Okay, so this is for safety purpose. I'm going to save this. Okay, now we are going to move on document loader. Okay, so AI cannot read directly or AI cannot understand directly raw PDF or text file. So we need to convert them into a small searchable chunks and store them in a vector DB. Okay, so that AI can find the answer. So that's why I use here this one, document processing. Okay, but before this I need to use embedding, guys. Sorry. Uh, First I need to convert text into a embedding. 1 minute. I'm just copy this embedding and paste it here. Okay, so here I use embedding. This is the function get embedding, return the Hugging Face embedding, and model name is sentence transform. Okay, so I use this model for embedding from Hugging Face. Okay, so it will convert text into a numeric format. Okay, model name is this sentence transform all min ln l6 v2. Okay, this is the embedding from Hugging Face. Okay, now AI cannot directly understand raw PDF and text file. So we need to convert them into a small searchable chunks and store them in a vector DB so the AI can answer later. Okay, so now I'm going to use document processing. Okay, so I'm going to copy from here. Okay, you can see here document loader. Okay, guys, so this is the function. This is the function, okay, for process the document. Here I pass the file name, okay, as a parameter. And here I mention suffix is equals to dot pdf if file name end with pdf else text. Okay, so it's check file type that it may be pdf or it may be text file. Okay, and here you can see save uploaded file temporary on a disk with the help of this. Okay, so here I'm going to save temporary file. Okay, save temporary file. So create a temporary file on a disk. With the temporary file, okay, named temporary file, I'm going to create temporary file on disk. Okay, and delete equals to false means file will not auto delete immediately. Okay, and suffix equals to suffix, it means it keep file type like pdf or text. Okay, as a temp. Okay, so this will use here temp equals to write and file dot read, it is going to read this file, and path name temp dot name. Okay, so here you can see this line, it this line means write uploaded file content into a temporary file. Okay, it is going to write the so dimension here, write uploaded file content into temporary temporary file. Okay, with the help of this line, and now we have this path. So get the path of this temporary file. So get the path of this temp file. Okay, with the help of this we will get the path of this temporary file. Okay, now you can see we have if suffix equals to pdf, then loader is equals to pdf path. Okay, if suffix equals to pdf. Okay, so here you can see here we are going to load document based on file type. Okay, if file equals to pdf, here we can use pdf loader. Okay, and if we have pdf file, then we can load pdf file. Okay, otherwise we will load text file. Okay, and it is for path and encoding utf-8. Okay, so here I mean we load the document based on the file type. Okay, encoding utf used for like text file. Okay, here this is the path of text file. Okay, and here we can load equals to loader dot load. Okay, load this document. Okay, now you can see here extract raw text from the document. Now, so here I mention extract raw text into small chunks. Okay, so here I load our document. Now splitter means here I'm going to use splitter means split big text into small chunks. Okay, splitter is going to split the big text into a small chunks with the help of recursive character text splitter. I took chunk size equals to 500. Okay, size of each chunk. Okay, and chunk overlapping equals to 100 means overlapping text for better context. Okay, okay, now we have these 4 lines, 5 lines. Okay, so here after chunk size, okay, we have chunk equals to splitter dot split document. Okay, so here chunk equals to splitter dot split document. So convert document into multiple small pieces here. Okay, so here I'm going to mention convert doc into multiple pieces. Okay, convert document into multiple pieces. Okay, chunk equals to splitter. I use this splitter and split the document. Here I pass the documents. Okay, and here I use embedding. Okay, embedding means convert text into a embedding. Okay, convert text into a numbers. Okay, so I use embedding here. AI understand number, not raw text, so that's why we need to convert into a embedding. Embedding equals to get embedding. I use this one. Okay, this function get embedding. Okay, and here after this, store embedding in a files vector database. We are going to store embedding here in a files vector database. Okay, okay, files dot form document. I pass here this chunk. Okay, means piece of multiple, I mean piece of document, multiple piece of document in the form of chunk. I pass here and I pass this embedding. Okay, in vector database. So everything I store I store embedding in files vector database. This allow fast similarity search. Okay, this allow fast similarity search later. Okay, so here you can see os dot remove path. It's mean delete temporary file for clean up the memory. Okay, and return the searchable AI database. Okay, return the searchable AI vector database. Okay, so this function takes a document, okay, and convert into a small chunks and turn those chunks into embedding and store them in a vector database. Okay, here, so the AI can search and answer question from it. Okay, okay, now after this we have this one, ask the question. Okay, I'm going to copy from here. Okay, still here now I'm going to use a file upload. Okay, so streamlit file upload give us file in memory, but most document loaded, okay, and need actual file path on disk. So here you can see, okay, now we move here in ask the question. Okay, so here we move here, ask the question. Okay guys, so this is for, like, you understand this temporary file. Okay, we create this temporary file. If user upload from UI, then it will delete after some time. Okay, the file. Okay, so now we are going to write code for ask the question from RAG. Okay, so here you can see we are going to define one function vector. Inside this I pass the vector store and question. Okay, so this is the vector store as a parameter and question user query. Okay, so this function is the brain of the chatbot. Okay, this function. This function is the brain of this chatbot. It take user question and find the most relevant part of the document, then send them to the AI model to generate the smart answer. Okay, so I use here retrieval. Step 1, convert vector database into a retrieval. Okay, so here we have vector database, vectors, okay, vector store. Here I'm going to convert this vector database into a retrieval by using L underscore retrieval. Okay, and here I use search keyword argument K3, means top 3 documents. Okay, so first convert database into a retriever. Why? So we can search similar content from the document. And K3 means K column 3 means top 3 result I want. Okay, and with the help of this doc equals to retrieval dot invoke question. Here document equals to, I'm going to use this retrieval. Retrieval means retrieve something and ask the question. Or here I'm going to ask the question. Okay, so here with the help of this, in step 2, get, here it has to get top 3 relevant document chunks. Okay, and why? Because AI should only use useful information, not full document. Okay, and here according to question it will generate the answer here. Okay, so here we ask the question here. Okay, and here we get the top 3 result by using retriever, and we are asking the question here. Okay, now we are going to combine. Okay, we are going to combine retrieval chunks into one context string. Okay, why? So we can give clean input to the model. Okay, so here you can see context equals to, I am going to join everything. Okay, join page dot content. Okay, this is the original content from the document. Okay, and here I am going to use LLM variable. I use chatgrok. Okay, so I use here grok model. I mean I use here grok API, so that's why I need to write here LLM equals to chatgrok. Okay, here I pass API key equals to API key, and model equals to this one, llama 3.18v instance. Okay, and temperature equals to 0.3. Okay, so temperature, low temperature means more accurate, less temperature means creative. Okay, so I need to write here 1.7. Okay, so after this, load grok LLM. Okay, so here we load the grok LLM model. This is the model that will generate final answer. Okay, now step 5 we have this one, generate the prompt. Okay, so prompt equals to, you are a helpful assistant, use only the context below. Okay, so step 5, create a prompt for AI. Okay, create a prompt for AI. Why? We force AI to only use give context, important for RAG. Okay, you are a helpful assistant, use only those contexts below. Okay, so context equals to context, I pass the question here, context and question, and answer in a simple language. Okay, and here you can see response. In step 6, we send prompt to the AI model and get the response here. Okay, so this is the variable. I use LLM and I invoke answer. Invoke means asking something. Okay, so I put here this prompt. Okay, I give here one context and user question. Okay, and return the response dot content. Okay, so in step 7, return the final answer to the UI. Okay guys, I hope you got it. So this is our simple code. Okay, first is for env file, I mean get the access of env file. Okay, and second is embedding, document processing, and here ask the question. Okay, and here I created prompt, and then it will give us response here and return the response in content, response of content here. Okay, I'm going to save this. Okay guys, so now I'm going to create this file app.py. Okay, so this is the front end of my RAG chatbot built using Streamlit. Okay, it handles the user interface where user upload document, ask question, and see AI generated answer. The backend logic like document processing and AI response is handled separately in our file. Okay, so this file is the UI of my chatbot where user upload the file and interact with the AI. Okay, so this is the Streamlist based front end that connect user input with a RAG backend and enable the document based question answering. Okay, so this file equals to in this file we are going to use button and chat processing. Okay, so you can see here, first I import this. Okay, here I import OS. Okay, here I import OS module help us to set the environment variable. Okay, so system setting, or here I use os dot environ. Okay, here I pass tfcpp min log level equals to 3. It means what? Okay, so these lines reduce the unnecessary warning from the deep libraries. Okay, and here we have this one also, os dot environ transformer verbosity equals to error. So this line this line show error from the transformer and ignore warning. Okay, and here I use streamlit as st for UI. Okay, streamlit is used to create a wave UI for chatbot. Okay, I import rag backend from this file. Rag backend, I'm going to import process document and ask question. You can see here I have process document, this function here, process document and ask question, this is my another code function. Okay, I use both of them. Okay, here. Okay, now after this use I'm going to set this. Okay, after importing, here I'm going to page setup. Okay, so here I mention in comments this is for page setup. Okay, this line here, this is for page setup. Okay guys, you got it. We use this document processing and ask question from backend rag. Okay, rag backend, this from this file. Okay, so import backend function here. Okay, okay, process the document and read the convert document into AI ready format. Okay, and read and convert document into AI ready format. Okay, and ask question here with the help of this function, ask question. Okay, ask AI question based on the document. Okay, so here you can see now we are going to use this page setup. Okay, I also put it inside in comments. Okay, so here in page setting you can see here st means streamlit. Okay, so st dot set page config. Okay, so this is the title of page. Okay, so with the help of this, set browser tab title and icon. Okay, I'm giving here simple rag chatbot, this is the title. Okay, and page icon, this one. Okay, st dot title simple document q&a bot. Okay, so this is the main heading show on web page. This one set the browser tab title and icon. Okay, and this one main heading shown on web page. Okay, web page. Now you can see here we have session state. Okay, session state, here you can see session state. So here I mention I am going to use this copy and paste it here. I replace this space here in session. Okay, so here this is the session state, memory storage. Should I mention here memory storage? Okay, so you can see here this one, if vector store. Okay, so store process document here in vector database. Okay, stores process document. Okay, if vector database not in st.session state. Okay, okay, if vector database not in session, in streamlit session, if vector store not in streamlit session, then streamlit state. Okay, session state dot vector store is equals to none. Okay, so it process document. Okay, with the help of vector database. Okay, initially if no document found, okay, so initially it is not going to load any document. Okay, so with the help of this line, no document here. Okay, if vector database not in session. okay, st dot session state, okay, then st dot session state dot vector database equals to none. Means initially we don't have any document loaded, okay, initially no document is loaded here, okay. if message if message not in st dot session state, okay, it means store chat history, it means store the chat history here in the form of message, store the chat history, message between user and AI, okay, message not in st dot session state, okay, then we store this message here, okay, st dot session state dot message I'm going to store here, okay. Okay, this is the empty chat history at start, स्टार्टिंग में एक एम्प्टी चेस हिस्ट्री है, यहाँ पर हम क्या करेंगे, वी आर गोइंग टू स्टोर मैसेज बिटवीन यूजर एंड एआई, ओके ओके। सो यहाँ भी इनिशियली कोई डॉक्यूमेंट लोड नहीं है वेक्टर्स में, ओके, जब हम लोड करेंगे तब पता चलेगा उसको कि इन्होंने कुछ लोड किया है, और यहाँ पर भी इनिशियली कोई चैटिंग नहीं है, जब हम चैटिंग करेंगे फिर हमारे मैसेज यूजर के मैसेज और एआई के मैसेज यहाँ पर स्टोर होंगे, ओके। हिस्ट्री empty chat history as of now, okay, and in the starting. Now we are going to upload the file. So here this is for upload the file. I'm going to copy from here this line and I'm going to move it here, okay, upload file. So you can see here file equals to st means stream delete. I'm going to upload file, okay. File should be in pdf or text, or type of file that is pdf and text, okay, nothing else. So upload files document in pdf or text, okay. So after this process document run once, okay. So now I'm going to copy this process document run once. Oh, I mentioned here process document, 1 minute. After uploading this one, I'm going to copy from here to here, here, okay. So you can see here this one only process document, okay, process document once. So I'm going to copy this line, okay, process document once if file and st.session state dot vector store is none, okay, it means only process if file is uploaded and not already processed, okay, only process if file is uploaded and not only processed, okay. सो यहाँ पर जब हमारी फाइल अपलोड होगी तभी हम प्रोसेस करेंगे, ओके। इफ फाइल एंड st.session.vector.store is none, okay. So here it means only process if file is uploaded and not already process, ठीक है। सो अगर हम यहाँ पर फाइल अपलोड करेंगे तो वो प्रोसेस करेगा विद st.spinner, spinner it is going to show you in spinner processing document, okay, in front end. And here in this line, with the help of this line, it is going to show you loading message while processing, okay. And this one st.session underscore state underscore vectors, sorry, state dot vectors store equals to process document file, okay. So it convert document into embedding, this convert document into embedding, you can see here it convert document into a embedding, okay. Process file, this one, it is going to convert it into a embedding, convert document into a embedding plus store in a files vector database, okay. And return, and here it will show you st.success document ready, okay. So success message after processing, okay. Now we have chat, I'm going to copy from here, okay. So chat history display, okay, this is for chat history display, okay. You can see here this line, I'm loop through all the previous message, okay. For message in st.session state.message, this is the loop through previous message, अगर आपकी कोई हिस्ट्री है तो उनमें ये लूप लगाएगा, ठीक है। inside this I already have this, okay, state session underscore state dot message mpt, okay. So for message in st dot session state dot session underscore state, this one, ओके, इसमें वो अपनी हिस्ट्री चेक करेगा मैसेज से. सो हियर loop through all the previous message here. Okay, okay, and here with the help of this line with st means streamlet. Okay, chat underscore message. Okay, so show the message in chat. If with st dot chat underscore message, it is going to show you message in the chat format. Okay, user or assistant message, so role may be user or assistant. Okay, so it is showing you message on chat like chatgpt. Okay, showing the message, so the message in chat format, user or assistant. Okay, st dot write message content means display message text. Okay, now we have user input section. So here I'm going to copy this, paste it here. I'm going to copy from here. Okay, now we have user input section. So this is our user input section, this one. Here I pass import. Okay, for example, question equals to st dot chat input, ask something from your document. Okay, so this is the question input box for user question. Okay, this is the input box for the user question. And after this we have processing user question. Okay, I'm going to copy from it. Okay, processing user question here. Okay, process user question. Okay, you can see here if user has type of question. Okay, if user has type a question. Okay, if user type a question here. Okay, so user has type a question here. If not, if no document uploaded. Okay, if no st dot session state vector store. Okay, if we don't upload any document. Okay, then it show the error. Okay, upload document first. Okay, and then stop execution here. Okay, now user message this one. So I mean here you can see after stop execution user message here. Okay, save user message here. Okay, save user message in a chat history. Again you can see st dot session state dot message append the user and question of user, content equals to question and role equals to user. ओके, तो यहाँ पर क्या हो रहा, सेव यूजर मैसेज इन चैट हिस्ट्री. ओके, एंड डिस्प्ले विद द हेल्प ऑफ दिस विथ st dot chat message user. Okay, and display user message on the screen. Okay, and here st dot write the question. Okay, it is going to display the user question on the screen with the help of these two lines. Okay, now get the AI answer. So here I have these two lines. I'm going to copy. Now AI answer. Okay, get the AI answer. Okay, so here you can see answer equals to ask underscore question session dot state dot session st dot session underscore state dot vector store and question here. Okay, so send the question. Here I'm going to send the question plus document data to AI and get the answer. Okay, so here send the question. You can see here I'm going to ask the question. So here I'm going to send the question plus document data because we have data inside the session state and vector store. Okay, so plus send the question plus document data to AI to get the answer here. Okay, and st dot session state message dot append. Okay, so save AI response in the chat history. Okay, with the help of this line we are going to save the AI response in a chat history. Okay, so inside this we are going to use to store the chat history. Okay, session underscore state. I stored the message. Okay, and chat history. Okay, and you chat history for the user and user question. Okay, so here you can see display AI result here. Okay, display AI response on the screen. Okay, so with the st dot underscore chat message assistant and st dot write the answer here. Okay, so this is simple process, guys. So now I'm going to open terminal. Okay, and I'm going to activate our virtual environment. Already activated our virtual environment. Okay, now I'm going to enter in our project folder. Okay, this is our project folder. I'm going to use clear screen, and here I'm going to run this command. Okay, we can run a streamlit file like this. Okay, streamlit run app.py, because this file I have everything in this file. Okay, okay guys, okay guys, so here I'm going to run this. It took some time. Okay, so I'm going to upload this document, guys. Okay, this one, where is it? Where is the document, guys, that I'm going to upload? Okay, I'm going to check here. I'm going to upload this document. Okay, this one, Python basics and core Python function and modular coding, file and error handling. Okay, so it will give us answer from this file. Okay, and guys, you can see here this ask underscore question. Here this one I use from this file, rag backend. Okay, this one, ask question. Okay, and after this we have another this one I also use this process document, where I use this here in this file. Okay, this one to process the document from here. Okay, this one. So I use two function from this. Okay, rag backend file in. So I use these two function here in app.py from rag backend. Okay, so we can check here in our browser. I'm going to click here. Okay, so I already use. Okay guys, now you can see here, this is our project. Okay, simple document question answering. Okay, so here I'm going to upload PDF file. So this is our Python complete teaching syllabus for beginner. Okay, it took some time. So guys, you can see here, this is the title, and this is the this is also the title. Here I already use this here. Okay, this one, simple reg chatbot, and this one also I also show you this icon here, this one. Okay, and this is the simple document question answering bot. Okay, I'm going to ask some question. Advanced Python library. Guys, I'm asking this question. Where is this? Advanced Python libraries, this one. So guys, this is the question I'm giving here. Okay, you can see here, this is the mess I'm going to send here, message. Okay, now it took some time to giving the answer, because you can see here it is going to run. Okay, it is giving us numpy, pandas, matplotlib. Okay, it is just use this. Okay, this one, where is this here? Okay, numpy, pandas, matplotlib, web development, and flask django. It is giving answer from this file. Okay, this file. Okay, but elaborate more according to AI. Okay, so with the help of AI, it it is it it is elaborating more here. Okay, you can see here data analysis. I have data analysis here. this one: NumPy, Pandas, Matplotlib, data analysis, web development, Flask, Django, everything it is going provide here. Okay, data analysis, NumPy, Pandas, Matplotlib, and second, web development, automation, machine learning. Okay, so these are the Python libraries, and it is generating this answer from this document. Okay. Okay guys, in machine learning, automation, Selenium, and beautiful soap, you can see here. So this answer from this document, बट इसने क्या किया है, इस आंसर को थोड़ा एलोबरेट करके दे दिया है. ओके, आप अगर कोई, इफ यू कैन यूज डिफरेंट डॉक्यूमेंट ऑल्सो हेयर. Okay, I'm going to ask another question: what is Python? So it is also giving the answer Python. Okay, I can ask second question: advanced Python. Okay, so here I'm giving advanced. Okay, so it is giving us, here are the topic covered in this phase: decorator, generator, iterator, context manager, multi-threading, multi-processing, regular expression, memory management, and virtual environment. Okay, so you can see here documentation in advanced Python: decorator, generator, iterator, context manager, multi-threading, multi-processing, regular expression, memory management, and virtual environment. These are in advanced Python. Okay, so guys, you can upload any document. It may be PDF, it may be text. Okay, in the form of text it will generate the answer like this. Okay, ये थोड़ा all elaborate करके देगा आपको. और okay, if it is unable to find the answer in your document, it will give the answer from Google, Wikipedia, or you can like, आपको अगर विकीपीडिया गूगल से आंसर नहीं जनरेट करवाना है तो आप स्ट्रिक्टली उसको मना कर सकते हो. ठीक है, आप लगा सकते हो उसमें एक कंडीशन कि प्लीज डोंट यूज गूगल, विकीपीडिया, use only my documents. Okay, so here you can see I got answer. Okay, first based on my document, and second also from my own document. Okay, so guys, basically rag, what is the rag? Okay, so with the help of rag we can use our document. Okay, I already show you, I use my document, this one. Okay, so basically AI search answer from internet, Google, Wikipedia, YouTube, AI using this. But with the help of rag we can use our own document or our own data. Okay, because my data is not present there in Google, okay, in Wikipedia. So that's why I can use rag, and with the help of rag we can use our database. Okay, so I hope you got this project. This is very nice. If you have doubt in comments, then please do comment, I will answer you. Or if you facing difficulty in Streamlit, okay, so you can read Streamlit here. Okay, this is the Streamlit framework. Okay, you can learn from here guys. We can use this Streamlit framework with AIML. Okay, a faster way to build and share data apps. Okay, turn your data script into a shareable web app in a minute. Okay, all in pure Python, no front end experience required. Okay, you can go and check this website. It is I'm going to open here. Okay, so okay, so this is very simple. You can use with Python. Okay, you can write like this. You need to install pip hello like this. You can use font type like this. Okay, you can create, you need to write like this, and you can create this. Okay, so this is front end. We can create this, I mean we can create front end with the help of this Streamlit for AIML project. Okay guys, so I hope you got it. We can create calendar like this with the help of this. This is very easy. Okay, if you have doubt, you can use this one. Okay, so this is our project. I already finished here. Bye bye, take care, see you. And please comment, mention the comment. Now what I am going to create. Okay, what you want, like I have finished LangChain. Now what you want, LangGraph, Llama Index, GUI, or AutoGen, what kind of framework you want that I'm create. Okay, so do comment, I will create for you. And I also create the project. If you have any project in your mind, so please do comments. Okay, and if you like my video, I hope you like my video. Okay, so please subscribe my YouTube channel. Bye bye, take care.